Oh, Nathan's live.
Oh, is he? I hadn't
Well, not
realised.
live. Oh, yeah.
Well, I think we're live. I would hope so. Well,
Yeah.
it's been a while. I have to say. I mean, I was a little bit, you know, been on my holidays, come off. I could have gone live yesterday. I could have gone live the night before, and I was a little bit, you know, bit of trepidation because I hadn't been on for a while. I suppose it's getting back
Nervous.
into the swing of things, isn't it?
Nervous, Ranty. Surely not.
Yeah,
Uh,
definitely. Definitely nervous, definitely. Anyway, guys, hello everybody in chat. We are joined by Spurs Chemo at the moment. I'm hoping that we'll get a few more people to join. I have actually created a group, so when they join, I'll announce them as they join. So, a few shout outs. So, Arwin was first in, Amanda Youngs, stopping traffic in my Rasta hat and flat out faith. They they lie Ohio, Carla Red Pill, Lori Lahato, Made in Texas, Jim R, Jimbo, Rodney Borden, Johnny Mosquito Strawman at Large, okay, Valley Parks, AJ&M, Delzac Hunt, Twitwit, CGI, Ranty, and Flat Out Faith. There we go. So that's everybody that I've seen in chat up to now. So yeah, kick the dust off indeed, and that's exactly what I'm doing. Back on the horse, so to speak. And here we go with another Flat Earth chit chat. So Spurs Chemo, we haven't spoken for a while. What's been going on with yourself recently?
I know you've been a busy man, Ranty.
You
Missed,
me?
wanted. Good to see you back. Yeah, I've been doing the usual debating, discussing. I was on Team Skeptics, or was it Fight the Flat Earth? But I was with Team Skeptic and Fight the Flat Earth and Sean Hofford. And, these guys are completely at a loss with the fact that they don't have science. So I think that's bewildering a lot of the ball earthers. So when you have these debates, they want to try and keep you away from science. So they, as I was destroying them with the heliocentric model is not scientific based, they wanted to focus solely on the flat Earth and why we believe the Earth is flat, or why it's not a globe and things like this. But mainly like the flat Earth model, or they're very desperate for a model. Why do you think that is, Randy? I mean, I've always asked them why do they need a model, and they kind of say for predictions, but it's not really. They don't seem to have a useful application for a model, right? Or can you see why we would need a model? Am I missing something?
Yeah, we don't need a model. I think the focus at the main point is essentially saying, hey guys, look, there's an issue with your model, and this is the issue with your model, seeing as you've had however many years to formulate this model, but we found issues with it, and these are the problems, and until these are addressed, we're always going to have this back and forth. I think over time, when new people join with different skills, more money to do different kind of things, then maybe we will be able to get a model as such. But up until now, I mean, it's very new, and we're all sort of like, there's some people over here and some people over there, and I mean, we even don't
Well,
have a proper answer. We're joined by Toady, by the way. Toady, are you there?
I'm here.
Good,
Hi, Spurs.
good
Nice to see you.
evening, good evening, good evening. Nice to see you too.
I
Uh,
followed your piece on Team Skeptic and that the other day. Yeah, it was very
oh,
interesting.
yeah. Well, we're just talking about models and whatnot, and so I mean, I understand the idea of predictions, but it's not like well, I don't want to get into a debate with you now. Actually, I was just trying to find out why you need the model, why you're desperate for a flat Earth model to.
I can put it really simply. I can do it really simply. For me personally as well, and this is probably lots of people, right? The ideas about the Earth and observations that we make about the Earth and space and other things are used for something. They're not just sort of vaguely interesting, right? They're actually used for things. A model helps us to make those predictions and then do things in the real world. If we haven't got sort of some kind of model that we can put together, it points to maybe the ideas are not complete or this thing's missing. And of course, our current model has got lots and lots of things missing in it. We look at the whole gravity debate and various other things. But obviously, there's some fundamental bits that we can model. We do make predictions, and then we do lots of real things with it. And that's why probably you'll find on our side, I don't like talking about sides, but certainly me, and I'm sure lots of others, want to hear those ideas because we understand things through those models. So rather than just being sort of chat, right, and I've got this idea of something, if it can be verified, that's very, very useful to us.
Okay. I mean, let's say you had a flat Earth model. How would that change anything?
For me, it would prove that there was some coherence between the different types of areas, like optics and obviously gravity and measurements and the heavens and those elements. It would prove that, and I would probably take it a lot more seriously. So I think today, and I'm sure Ranty will come on to talk about it, so I don't want to sort of blow it all, but there were some very interesting observations made of a particular picture, and it didn't work out. People are going to hate me for this on the globe side, but it probably wasn't the best example, right, in terms of the globe side, but it was a real picture and it was really analysed, and it raised a few questions which are interesting, and that's why looking at things through that angle, I think, is a good thing to do, because then we can find out more about the world. And it certainly showed me that waves and the sea can definitely have some effect, certainly in blocking things, which probably shouldn't be a surprise, but yeah. It was interesting, and I'm sure Randy will cover it a bit later. But I think it was a very interesting, good, practical example. And by having a model, we can understand and unpick that picture.
Yeah, I mean, that image. I mean, we didn't have the full information, so obviously, I'm sure when RK ever decides to get around to releasing the metadata and stuff, we'll be able to check out tide heights, etc., etc. Maybe the tide heights were incorrect, who knows, but from the information that was provided at the time that they gave us, essentially it didn't match out to the globe model. Now, whether or not that's still the case, whether or not he got his tide times right, whether he's got his elevation heights right, we don't know, and without actually knowing that particular land, like I know where I live, heading up to Barrow, we know the topography of the land there. I've studied it, so with Alkay having very little informed information of the location, even to know that in the Firth of Forth that they have 4 tides every day rather than just 2, that seemed new information to him. So for somebody that films in that location quite a lot, you would think that he would already have nailed that information down. The fact that he hasn't shows that he just goes out, takes his images, and he doesn't take it as serious as perhaps flat earthers do when they go out and do the research and understand all the different things that are going on. But I mean, I'm happy if he wants to come back and share his metadata. We'll work through the image, but certainly it didn't. If it was to be believed, there would be more curvature. We'd live on a smaller ball. That's
right. So I'd correct it. I'd correct it on one thing. I would say you're right if it was to be believed. So my point is, at the beginning when I saw the picture, I definitely would have sat there saying this is a proof of curvature of the horizon. Okay. Mm-hmm. By the end, I wouldn't make that statement. I wouldn't have been as bold, right? Having seen the analysis, and it would probably make me be a little bit more cautious in future as well. What it told me, which is I guess why people are getting, excited about it, was that there are significant tidal effects. All right. Now, whether we debate whether there's a horizon or not, there are certainly significant water effects that can block buildings, and it may turn out that actually it was all fine or whatever. I guess the issue with the photo is that if it was a flat Earth, theoretically, I suppose we should have seen all the way. If it's a ball Earth, we should have seen a little bit more as well, also of it. Like less should have been blocked. So clearly, the tide and the water appears to, from what we know about that picture at the moment, I'm being cautious, have a much bigger effect. And as you say, if we took that as a horizon and a measurement, we'd be on a much smaller ball, which kind of shows you how far maybe these images can go, and the fact we need more information. Which I think, Ranty, the interesting thing for me is, and I've been talking, but the idea hasn't really been taken up. I understand why it's a bit of work to do. A couple of things would be nice. One would be, and you may have heard me say this on the Jose's show the other day, one would be almost some ideal some exemplars, some pictures that show each of the types of effect, right? Miraging, one kind of refraction, another kind of refraction, stretching, compression, whatever. A set of images that says this is this effect happening. And the second would be a guide to people taking photos of this, the basic data to collect. Because I'm going to start taking some photos now. I've got my P900. It would be helpful to know, and obviously I'll probably try and record my elevation. Well, I will try and record my elevation, where I am, what I might try and record that as well. But then maybe I've just missed something in that list. Do you see what I mean? So it might be useful also just to have a very quick snippet somewhere that we could all access to say these are the things you need to nail. Because as you say, Alkay was missing some bits and pieces, and I don't know if he was keeping them back because they didn't help the debate. I'm not saying that is the case. That could be one point, or maybe he hasn't got them. Maybe he didn't record them, as you say. So I think it'd be useful to know what we record going forwards as well. Do you see what I mean? The base information we need.
Yeah, well, I always try to be very concise with everything. I always do a pan around. I just don't show an image. I mean, the trouble with that image is that you saw an image and there was nothing else to go with it. Every time I've done my photography and stuff like that, I've always put it out there with the metadata and stuff, showing everybody where I am, what my observer height was. I'll generally do a video that goes along with it. And I can say this is me taking a video immediately after I took this image or something like that, to show you exactly where I am. So I learned that very early on, and that was through the Globers attacking me for presenting exactly the same thing that Alkay did. So Alkay presented just an image, which is something that I've done in the past. I've presented an image of Blackpool Tower from Hoy Lake, 29.3 miles away. And because we had no corroborating evidence apart from the metadata, so we had no video to go along with it or anything like that to actually prove exactly where we were, etc., etc. We just thought that would be enough. Now that was me and Tony way back in our very early days, as when we first got into this debate, and we received so much grief from that we learned very quickly that you have to do all this stuff. You have to tell everybody everything because people will scrutinize every single aspect of what you're presenting, and that's the whole thing. So I wasn't being negative with Alkay. I wasn't having a go at him or anything like that. I certainly didn't do that. I just wanted the information, and the information was very ambiguous. He wasn't too sure about his tide height. He wasn't too sure about when the image was actually taken. His distances, he quoted 16 miles was the distance. When we measured it on Google Earth, it was 10.8, and that's a huge difference in distances. There was a whole bunch of things. We couldn't even just to get the elevations of the building that we were trying to observe. Again, that was very difficult because it's, Google Earth gave I think 14 meters, but the Ordnance Survey gave 10 meters. And yet, if you go to a citation from the internet, somebody that was basically just making a guess, he guessed it at 7.5 meters. Now that's a massive swing. 7.5 meters to 14 meters in elevation above mean sea level over a distance of just 10.8 miles. I mean, that is such a difference.
It's a huge variant. Yeah, it's
a huge variant.
I can see very quick. I can see Rumpus jumping up and down in the chat, shouting at me, saying that I'm wrong and I'm this and the other. I think the point is a general one, Rumpus. Right? There may be new information. It may all be correct. Right? I pick my words carefully. The point is, from what we went through earlier, and I think Ranty's point is well made. We probably need more information when we're doing these kind of analysis, if we do these kind of analysis. And for me, it's not about the right or wrong. It's just because trying to be right all the time is, clearly there was stuff missing, right? The answers were not there this afternoon. They may have been found. That's fantastic. But for me, I don't need to always go and find that. It's probably better to improve the technique or get better information when we're doing these kind of observations. Yeah. So I think it kind of misses the point. If maybe now it's all fine, that's great. It's not really for me about this particular observation. It's generally about the process of observation, I guess, is the point I'd like to make. Which I'm sure you agree with, Ranty, right? That we should have as much information as possible as you've outlined.
Yeah, exactly. I mean, as I say, we learnt the hard way from dealing with people just like the Rumpus, who has been lingering around this debate for as long as I can remember, anyway. So people just like him who used to criticise us for the work we did and the way we presented our information is exactly the same as what I was doing to Alkay. And I appreciate that they may have gone through some stuff after I left and after the show finished, who knows? And if that's the case, so be it. But at the time that the presentation was made, there was no data to be taken other than it wasn't supportive of the globe, and could be demonstrated that the building that we were looking at was being obscured by water, clearly just water, but in an area which is renowned for things like it even has a tidal bore there, and Al-Kaiti didn't even know that, so the area even has a tidal bore running up that channel. So there's a whole bunch of things there that could lead up to a bunch of obstruction caused by water, and I just think that area, like I've written off Barrow Furnace, not Barrow Furnace as in, but the estuary that leads in towards Heysham. I've written that off. I've written that channel off because that channel is so terrible for obstruction. I mean, you can get a boat hidden behind water from just like 7 miles away, a whole boat, just because of this tidal bore effect. It's ridiculous. So, I mean, I think those sort of areas should be scrapped from observations. And if you're going to do things along the coast, perhaps, rather than in places that are subject to this kind of effect.
So I agree. I think there were two good things for me today, and I agree with you, by the way. I think there's probably areas which it's not very good taking observations from because there's a lot of anomalous effects there or something, right? And we don't want to get lots of evidence of lots of anomalies, right? That's probably not helping the debate. I think what was very good though, Ranty, was going through between us, right? It was pretty civil. I know there was a bit of back and forth, wasn't there? But generally, I think it was okay. But it wasn't a big shouting match, yeah.
Yep.
And it was really good working together, gathering the evidence of the observations and testing the theories. Yeah, whichever way we may conclude it vaguely came out, or if it's whatever the result, right? I think for me, it was the process as well, which was very good, of having you there with your deep expertise of these things, because I think it's too easy, and I probably do it myself, to fall into the traps of just the normal rhetoric, right? So I think when you're challenged, you play a better game, yeah? So I think it would be really nice to do some more of those, but maybe with more information. If we pick a few observations where someone's got better information. Do you see what I mean? And then do it live again like we did and try and, maybe not debunk's the wrong word, but investigate it, yeah? It was very satisfying for me.
Yeah, well, we're all here for the truth, and that's the thing, see? I mean, this is what my whole channel is about. It's inviting the Globers to come in and make presentations and try to understand what's exactly going on. So I would expect the same back from them, what they give to us. Now, they gave us a lot of grief when we first started off about these observations. We tightened the ship, and we were able to show incredible distances of, essentially shore to shore. Now, in those cases, we're told that these things are being loomed up by some miraculous miraging effect caused by the atmosphere that is able to lift entire landscapes and buildings all up in proportion, all at once, without them wiggling or moving. And you just, but as the observer, you're just looking. You're not looking at a hologram. You're looking at a building or a distant landmass. You can see. You're not looking at a hologram, right? You just know you're not looking at a hologram, and to be told that this is what you're looking at, and yet when you try to counter with real world, things that can happen and things that can cause obstruction with water, they are dismissed. And there's always an angle to try and come in at. Well, maybe the elevation was another foot higher or a foot lower, or maybe the landmass isn't quite 3 meters, but it's 4 meters, and maybe there's this stand. It's just when you listen to the amount of garbage. I'm sorry, but Toady, when you listen to the amount of garbage that comes back from the Globers, when we're very honest with what we see, and we show it, and you're not looking at a hologram. Tell me you know that you're not looking at holograms when you see a building in the distance and you're being told that it's being loomed up. I mean, do you believe that?
In which particular picture?
Any picture. Apart from the ones that are clearly very wavy and distorted and look kind of really, but real buildings, just across a flat plane. For instance, Red Pill Philosophy, you've seen his video, yeah?
Perhaps not. What's it of? Trying to remind me.
He's in Florida and he's looking across a bay or something in Florida.
Oh yeah, I didn't actually find that one particularly good. I've seen others that are actually better. Yeah, I do know the Red Pill. Yeah. Well, maybe I'm thinking of a different video. It's always possible, isn't it? Because he's got some islands. Yeah. Um, yeah. So we could be talking about a different video. So if you want to share it and have a look, I'm happy to have a look. Rumpus is very worried I'm going to say something stupid. I think what I would say is
he
that
needs
there
to
is
stop.
standards.
He needs to stop micromanaging what you
Agreed.
say. Right?
Agreed.
You're your own person. Right? At the end
Agreed.
of the
And
day.
I think that there is a little bit too much, generally, of rather than looking at the observations, trying to find data to fit a model, right? And I think it's probably better that we go step by step. Not that the model's not important. Do you see what I mean?
Yeah.
But I just think there wasn't probably enough information about that one earlier, right? And that's why I'm trying to look for how can we get more information so we can all look at these observations sort of sensibly and properly. Because I do notice the tendency that you say, right? And it's I do it myself, yeah, leading the witness a bit, right? Oh, could it have been this? Could it have been that? And you can play with numbers, and as I know, I've got a lot of accountancy experience. You can make things look one way or another, and that's why I think having the information about these observations is very important. And I will go and have a look at this red pill chap and see if it's the ones that you mean of Florida. I've not really seen a lot of evidence of looming.
Well, Chemo, you're still here, right? Yeah. So you were with me when we went down to North Wales. And I went down, you came up, we met in the middle, we went to North Wales. We were actually with a guy called Rude Earther, so if he's in chat, hello Rude Earther, thank you very much. He hired a boat and he went out past the turbines and he headed out to an oil refiner or a platform out there. And we filmed him. And Chemo, you were there, you saw it. Do you think you were looking at a hologram of those boats, or do you actually think you were just looking at the boats?
Well, it was obvious, it was clear. I mean, you're following the boat, and it's not going to just disappear and then re-emerge as a hologram, is it? So, where they get this hologram idea, you'd have to have extreme heat or a lot of heat mixed with the cold air. And that wasn't happening that day, was it? It wasn't really a warm day. It was.
It was quite cold actually, because I remember we were freezing on the shore.
Right. So to get a mirage like that.
Well, you don't even need to go into that honestly, you don't need. As far as I'm concerned, I've never found any sign of looming ever, and I've done all kinds of different tests to try and look for looming. I've tried to find it, can't find it. Ever, never experienced it. Same place every single time. I have a post that's 4 miles away from my exact spot where I film every single time. There's a building 18.3 miles further, from where I am, so 14.3 miles beyond the post with a star on, like so, it's about a foot height, this star on the top of this post. And every single time for over a year that I went down there and filmed those buildings from the same spot, the building in the background stayed exactly in the same position as the star in the foreground. That star on the post that was 4 miles away was always in exactly the same position as in the building behind it, proving there was no parallax difference. It's not like the building behind it was raised higher than the star in the foreground or lower. It was always in perfect symmetry every single time.
No, I see what you mean. It was lined up, right? So the star was always in whatever the position was on the background, yeah. So they'd both have to move if they were looming, I suppose, yeah.
Well, yeah. If the building's in the distance or over a greater distance, you get this effect of looming, right? So if there was any kind of looming happening on the day, then those buildings would have been in a different relative position to the post in the foreground. That didn't happen ever. The only thing that happened was we saw some days with an inferior mirage and some days without an inferior mirage. Right? And when you didn't see an inferior mirage, you saw shore to shore, and all the calculations said that you were seeing far further than you should on a globe. Right?
And that's what I was going to get to is, so you were seeing further than you should on a globe, and you've done multiple observations there.
Yep.
Is that particular bit available in your channel? Has someone tried to sort of take that apart or debunk that? Because that sounds to me like a number of observations, right? So it's not just one time. Sounds like you've done it a few times.
That's true.
Has anyone looked at that?
I'm actually, all this time that we've been talking, I've been looking through some of my database, right? I'm on my PC trying to find a set of images that I was going to show you about how waves can obscure things in the distance. and I keep looking, so people are probably seeing me chat, seeing my eyes jotting all over the place. I have that much data, I still can't find the images that I'm looking for. So we've been going now for 25 minutes. So for 25 minutes I've been trying to find, this is how many observations and images I have, right? I still can't find what I'm looking for. But the point still remains that, yeah, I've presented this on numerous different channels. It's not like anybody's come back and said to me, there's a reason for this. Or this can be explained by this. Or the inferior mirage isn't what you think it is, you know. Because in fact, they changed their opinion. 2 years ago it was globe Earth proof, that's where the curve of the Earth starts. You know, now suddenly, we know about inferior mirages. Yeah. Well, no, they didn't, because I received so much grief for that. So much grief for my work on inferior mirages that, you know, at one point I think the flat earthers deserted me because they didn't agree with me showing what would apparently look like curvature to other people. But the body of work that I built up was able to show, okay, well, the inferior mirage is what causes the blockage. And I was able to demonstrate it, prove it, with repeated tests over and over and over and over and over again. No sign of looming, nothing like that, just shore-to-shore observations when there isn't an inferior mirage. And, you know, other days that you do see physical blockage of the water, explained away by, that's how I found out there was a tidal bore in the area. You know, and I wasn't even aware of that, but I had to find this stuff out. And it's called research. It's just what it is. And, you know, there's literally hundreds and hundreds and hundreds of videos that I don't have, thousands of videos that I don't have on my channel that show all this, but I have showed them in the past on like Nathan Oakley 1980s channel and stuff like that.
All right. I mean, it's difficult, isn't it, to go for a big archive of stuff. I find that too with all my stuff I've taken over the years. Not of these are kind of observations, but other stuff to collate it. I think what would be, for me, really interesting is if you do get time or you know where you've got some of it, Renty, if you could point me towards, let's say, I don't know, just say 8, 10, I'm just picking a number, of observations at the same place where you've gone there repeatedly and you've seen too far, I don't know, 8, 10 times, and maybe sometimes when you haven't seen too far, it doesn't matter. Yeah, because that would be interesting to analyse. So I think I'd be really interested in looking at that.
Yeah, but Tony, for me, I mean, Tony, let's say...
Hang on one sec. We are joined by Gleam. We're joined by Gleam. Gleam, are you there?
Hello, can you hear me? Mic check 1. Mic check 1.
Evening, Gleam.
Check 2.
Glad to have you here.
Salute Sperskimo. Salute Toadie. Salute Ranty.
Salut.
Gleam. Nice to hear
from
you.
I'm a bit merry. I'm half a honey Jack Daniels down. It was my birthday yesterday, so I'm making up for it tonight.
Oh well, congratulations.
Happy
Come
birthday,
to us
mate. Happy birthday.
once a year.
Happy
Too old, don't remind me.
to you.
Woo! Can I drop in just one big bombshell? Massive bombshell of a question. Toadie, to you, sir. Salute to you, sir. But can I ask you, can you name one single globe earther who has ever made any account for any wave height in their life on any orthographic view? Can you name one offhand, or
What do you mean by account for it?
okay? Because put it this way, here we go. Recent observation from the globe Earth community saying yes, we've confirmed globe Earth and flat Earth debunked. Wolfie in Perth on his Bathurst lighthouse. Sorry if I slur, that is purely Jack Daniels' fault. But either way, so he basically put it this way. I treat Wolfie like this, where I just drop on every single one of his videos in a negative way, but just to show that the one question I asked was, what account did you make for the wave height? He said, I looked into it, but it didn't matter, so I didn't include it. It was too negligible to even bother with. Now, when you look at the wave height in between Bathurst Lighthouse and where he was actually taking his point of view from in Perth, you find there's a 3-meter wave. If you dissect the actual vision or the distance between him and the actual lighthouse, even on a globe, that's Jack Daniels again. Even on a globe, the apex is still 1.5 meters above the actual mean sea level. Therefore, a blockage must take place on a globe, regardless, in comparison to mean sea level, calm sea, flat sea on a globe.
Yeah, I mean, obviously, if there is a wave there, it will cause something. I mean, I think I don't know if were you listening earlier when Rumpus tried to explain this interesting phenomenon of moving the 3 feet forwards, which me and Jose, I think, were not totally convinced by, probably because I'm an idiot, right? But this idea...
You're not an idiot. You're an utter idiot. Sorry, Jack Daniels.
Yeah, I think he's saying that from the chat already as well. He's already saying that I'm talking garbage. It isn't. It's just a slight incomplete understanding, right? I absolutely understand geometrically how it works. Totally go along with that. But when I've seen observations, I just need a little bit more convincing, right? And I think Barney is going away to look at that, because I think it is an interesting point that if you're low down, there's a lot of stuff that can start obscuring things, and then obviously it can block things that are a long way away. So I think it's an interesting point, and that's why I'd love to see the stuff Ranty was talking about, right? If he has a chance to get me whatever 8 or 10 images from somewhere, so I'd like to do a bit of analysis on that, because I want to spend my time doing something that's worth looking at. Do you see what I mean? Not lots of nebulous stuff. Yeah. Because it's a fascinating topic, and I think
Sorry. Are you all right?
I think that's the plain truth.
That's me. Hello.
Oh, it's plain truth. Blessed plain truth. Salute.
Oh, Travis. Hi, Travis.
It's an honor and a privilege, gentlemen. An honor and a privilege.
It's like you just drove into my living room.
Hello.
Hey, so Toady, let me suggest, maybe, since I'm already collaborating.
Yep, with Barney.
That I can send you the images that I sent him.
Yeah, I'd love to look at them. I'd love to look at them.
You know what I mean? Because then if the two of you are working from 2 different vantage points, you've
Brilliant.
got 2 different.
Perfect. Yeah.
So I'd be willing to send you that stuff.
Yeah. That'd be good. Yeah.
Can I also give you a secret cheat sheet? A cheat sheet to do with Ranty's exact observations, and it's a YouTube channel called Heath Carmoody. He recently shut Sly Sparkane up. Sly Sparkane put out a challenge to say how many flat earthers can guess, and it was all he showed is a dolly scroll from side to side of a ball that was X a distance. No one knows the distance. And from angular size alone and the actual degree measurement that he said he slid along, you had to work out how far it was away and how big the actual ball was. Heath Carmoody has actually designed a flat Earth versus a globe Earth curvature calculator, which is in 3D using the Unreal Engine. Amazingly impressed I am, regardless of whether it's true or not. The guy's put hours into it. And what he's actually done is he's created kind of like a ray tracer in a manual format where it will account for compression and it will account for refraction in a slow term, let's say. But he's analysed some of Ranty's pictures on the lettering of the side of the ferry. And he's done some bits on that. And put it this way, he showed Sly up by basically getting near as damn it for the calculation on that ball test, on that ball challenge. So Heath Carmoody is definitely a good person to look into.
I'll go and have a look at that. Who's sharing something on the screen? That looks like, is that a lighthouse or a pole or? Yeah,
so that's the post in the foreground that I'm talking about. So when I think that post is around about 20 feet, 16 feet to 20 feet. It's something like that. This metal marker thing that's in the foreground, and from my observation here, this is off the beach, so it's around about 4 miles away from the beach, but it's certainly 4 miles away from the railings. But by means of triangulation, because I walked onto the beach and was a bit further away, it's still about 4 miles away. So this is from an elevation. Both of these images were taken from an elevation of about 2 feet above actual sea level. Right, from the same spot.
So you were like crouching down with your camera.
Yes, and both on one particular day, it was absolutely flat as a pancake. This is the image on the left, and on the image on the right, we had a little bit of chop, not much, maybe a foot or two, but some of the waves were slightly higher than the other. Now, there's a green part that's in the left-hand image. If I sort of like hover over this, maybe you can see, I don't know if you can see it, but on the left-hand image, there's a green thing behind it. Now, that's actually a mock-up of a crane that used to work on the docks there. So it's actually just a big pretendy kind of crane, but it's around about 80 feet tall, right? Now, can you see the waves in the foreground? Can you see how
the left-hand picture?
The waves on the right-hand side now? So where
Right. So I was going to ask about that, but you'll start getting upset when I ask my questions. But yep.
So the waves on the right, which are only maybe a foot or two high, are actually obscuring the entire 80-foot high mock crane, in the background behind the post.
That's what I was going to ask, because it looks to me like those waves are pretty close to you, not a long way away.
Yeah, I would imagine there's somewhere between 80 and 100 feet away, something like that.
Okay, right, yeah, 80 to 100 feet, yeah.
Yeah.
And they are obscuring half that pole, aren't they?
Yes, they are. They're obscuring half the pole, and they're certainly obscuring that distant building. Obviously, we know things get smaller with distance, so obviously that's lowered its actual height, well, perceived actual height. But the wave in the foreground is clearly obscuring that. And this is what can happen on certain days. Now, this is only a small wave in relation to anything else, because on that particular day, on the one on the right, it just seemed like it wasn't a bad day, which is why I walked out all the way to the shoreline. You know, because the tide was out, so I had to walk all the way down to the shore. It's about a quarter of a mile walk, good quarter of a mile walk. But I walked down because it was a relatively calm day. But still, there was a little bit of chop. You know, it wasn't as absolutely still as the one on the left, but this is what we were seeing. This was obstruction that we were getting.
So a couple of questions.
Hey, Ranty.
Oh,
Sure.
sorry, go on first.
So is the image on the left your image?
Yeah, both of these are my images. Yeah.
Okay, right. So then we're looking at the same distance and same focal length and height.
Yes.
Okay. So I'm curious if is that a still shot on the right, or is it an image from video?
The one on the right is an image, and the one on the left was taken from a video. Sorry, the one on the left was the one on the left was taken from an image,
right.
and the one on the right was taken from a video.
Because that was my question, Travis, as to why it's blurred and not as in focus as the other one.
That's neither here nor there for me, right? But I guess my question would be, in terms of what I'm looking at right now, there's obvious height difference on the tower, so that's going to be ether bandy. But I'm wondering if you've got maybe the image on the right. Do you have it where there aren't any waves, so that you can kind of just compare that as well, just out of curiosity?
The image on the right is the same as the image on the left.
No. I'm asking you for another image of the. I'm sorry. The image on the right has waves that are obstructing, right? So, do you have other images that are similar in terms of the same day that you're shooting, where the waves aren't as high per se, maybe a little bit less rough?
With the blur, basically.
I would need to look for that, but I would certainly need to look for it. I don't have it right now.
Yeah, and I just want to apologize, Ranty. Like last year when you were doing some presentations on Nathan Oakley, and you were thinking, now where did I put that file? I was thinking to myself, label your shit, Ranty. Come on, man. And now I'm in your camp, and I'm like, where did I put that file? I can't remember where.
Data nightmare.
So my question, Ranty, really on looking at this picture is, it would seem in this one that maybe the waves are higher than the 2 foot you are off the floor, and that's why it's blocking, I don't know, more than half.
It's
half of the pole.
It's quite possible. I mean, we do know that whatever height of the waves are given on a certain day, that's always 1 in 8. So 1 in 8 of those waves will be higher than the given height. So if they tell you it's a 2 foot wave in the area, right, you can always know that 1 in 8 of these waves will be higher than 2 feet. The majority will be around about 2 feet. But it's for boating observation. It's for when you're boating. So they need to have a sort of like an idea of what the weather's going to be like on the oceans. When you're doing observations, though, you're looking across thousands of waves. So you always need to increase, take the higher, because you'll be looking across every eighth wave. Every eighth wave you'll be looking across will be higher than 2 feet that's given. So you can always add an extra half a foot or even a foot higher, just because they always give you a mean.
They give you the mean and not not the maximum. I get that. Go on, sorry.
I was going to say, can I make an observation in between the two views as well, though? And forgive me if Jack Daniels creeps out, but I'm sure that the sun's direction on the left-hand side one is actually coming from the top right-hand side, whereas on the right-hand side one, it's coming from the top left-hand side. Therefore, the colour would be less pronounced anyway, regardless of the blurring and whatnot. If you can see the shadows on where they're actually touching and how bright it is.
Yeah, I'm pretty sure that it was around about 10:30 a.m. when I took the images on the left, 10 o'clock or 10:30 a.m. and I genuinely cannot remember what time it was that I did this. I would imagine it was probably at the same time, because I always seem to do I always went and did my footage in the morning before work. You know, it was rare that I went down in the afternoon, so I would imagine they were probably taken at a similar time. But the reason you get this brownness and greyness in the sea is because of the amount of sand that's being churned up from the bottom. So when you've got a lot of swell and chop and anything like that, you get this kind of colour. But on this particular day, or whenever you get a day when it's really blue, that tells you that there's no swell going on. The sediment at the bottom isn't being pushed up and mixed with the water at the top. It's settled at the bottom, and all you're left with is the nicer, clearer water at the top. So on this particular day, it was an exceptionally good day, as you can tell. This is a shore-to-shore observation, bearing in mind, at 18 miles. So this is the lighthouse in the foreground that's a distance of, I think, 13.6 or something like that. That's the lighthouse that's behind this post.
Is it? That's the lighthouse. I thought it was a bit of that crane. Okay.
No, that's the lighthouse there. That's the sandbank that's in front of it, and literally that's the shore. You know, this is the shoreline, and behind it there's a crane in Barrow-in-Furness, and I think that's about 17.5 miles away. So,
is this maximum zoom, optical zoom as well, Ranty, the one on the left, the really clear picture?
No. In actual fact, I didn't realise what I was filming on this day. I've got a series of images of these. I didn't realise what a good observation it was. If I had done, I'd have stayed there all day. But
because it was clear, isn't it? Really nice and clear. Fantastic.
I think I got about 20 images on this particular day. I got about 20 images of this area. So I've got a full-on image of the lighthouse. I've got all kinds of different stuff, all from an observation of a foot and a half, a foot mainly. This image I had to move back, and when I moved back, it put me behind this post. So I had to get into a different position to actually take this image. But all the other images were taken from a foot, and they were where you saw the lighthouse on this side of the post. And I just stepped back around it because the tide started to come in, you see, so I had to move back. So as I moved back, it changed the relative position of this lighthouse behind the post, which is why a part of it's obscured.
Ranty?
Yes.
I remembered my other question. If the image on the right were not, if the image on the right were calm and there weren't any waves, where would you place the water line?
Again, I've only tried to match it up by what I'm assuming is the top of this post. So it's really difficult to say. I mean, I couldn't guess. I imagine it would be similar to this one here. If it was absolutely flat, it would be similar. Maybe a few pixels out. Who knows?
Yeah. So the reason why I ask is because in the Chesapeake Bay where I shoot, if I were to compare my channel marker to your image on the left, so you've got that post, I would have a contrast of images where the water line would actually extend farther beyond the post than it is right now, if you understand what I mean.
Right, okay, so
I've got images with the channel marker where the water line is really tight to the channel marker, and I also have images from the same location, same height, same everything.
Yeah.
And the water line extends farther and higher, as it were.
Have you checked the swell details on that day? Because swell will play a part in that. So it might show the tide times might be the same, right? So you've got the same tide height, but that doesn't include any kind of swell. So on this day there was no swell whatsoever. You know what swell is, don't you? So if you stood at the shoreline and you get a wave lap up, and then another one laps up, and then a third one laps up, and then the fourth one is a big bastard wave that drenches you, right? Because I've had it lots of times, right? And you get little wave, little wave, little wave, big wave, right? Well, the little waves are just your normal, everyday, wind-driven waves. The chop is that fourth wave, that big wave that comes in every fourth or fifth wave that comes up. Now, they're longer in duration, so they can be anywhere from, say, 14 seconds to maybe as long as 30 seconds in length. So these are big waves, right? And they have a separate height. They're like a body of water all of themselves. They aren't included in the height of the tide.
Yeah, so the difference between where you're looking and where I'm looking is that I've got the Susquehanna River. So it's flowing, but there aren't tides per se. Now, I do have a higher water level at sometimes and a lower water level, so there is a certain, I would say, tidal input, but it's not, I don't have sets of waves. The only time I have waves is if it's really stormy or if a boat goes by.
I get you. Well, you're learning, though. That's the thing. You're learning through your experience. Hello?
You may have hit a dead cell area.
Yeah. Thanks, Dad. Yeah.
Yeah, but yeah. I mean, you're just learning by your own. You're noticing things that are affecting it. So you just said there, and then you notice when a boat goes through, that changes things. Well, because obviously it creates a wake, doesn't it? And that stirs things up. We were watching a video today with Jose, and he had a channel, and he had the tide coming in, and we had a little area that was being churned up, and that hid an entire boat behind it. And he should have had clear line of sight to that boat. And even Jose was like, yeah, well, these things happen. Water can hide stuff.
Yeah, that was a bit I found odd, whether that boat was theoretically behind the horizon or not, because it looked like it wasn't, and I think Jose said it wasn't. I think later on Rumpus said it had to be or something, because that's what made me wonder about this whole, if you're below the height of the wave, clearly it can block stuff, like this picture. Yeah, no real argument there. But it's what happens when you're above it. And it did look like that wave blocked a lot, didn't it, that came in on that video we saw on Jose's, which sets me wondering.
You've just got to be very careful with just seeing an image and saying, I mean, Gleam hit it on the head perfectly before when he turned around and he said, what about Wolfie when he talks about his observations at Rottnest Island? He did an observation one time where he went to the top of a hill and he filmed Rottnest Island with the lighthouse, and then he went down to the shoreline and he quotes his elevation between 5 and 6 feet above sea level, where he puts his camera and he films Rottnest Island, and you see part of the lighthouse obscured, right? So this is a video that was perhaps 18 months or 2 years old. It's one of his more famous videos, right? And this is what got me looking into his observations in that location and what's going on with the swell there. Then you find out that in that area you get anywhere from, an average swell height in the area is between 2 and 3 meters, right? And quite often you go as high as 5 meters in swell alone. So him at the shoreline would have been looking across a body of water that had swell anywhere in length from, say, 14 seconds to 20 seconds or 30 seconds in length, that was artificially increasing the height of the water by, it's always half of what the swell is. So if the swell is, say, quoted as being 3 meters, then half of it will be the swell height and half of it will be the swell trough. So the swell, you've got the peak, you've got the trough. If it's a 3 meter swell, you've got 1.5 meters of obstruction from where your feet are at the shoreline. So if his observational height is 5 feet, he's looking directly at the top of the waterline, right? On those days.
I see what you mean. So the swell could account for a lot of blockage. Yeah.
Yep. And then on top of the swell, you get the wind-driven height. So you can estimate the height of the wind-driven heights by the actual speed of the wind. There's a chart out there that you can actually look at, and it will say to you, I think it's around about 18 miles per hour. If you get an 18 mile per hour wind, I think that's about 30 kilometers an hour. So if you've got a 30 kilometer an hour wind, you get waves around about 4 feet high. So if you've got 4 feet wave heights on top of the swell height, well, you're never going to see very far, are you? At all, ever. Especially if you're just a human stood at the shoreline and you're 6 feet tall. If you've got a 3 meter swell and it's a 30 kilometer an hour wind, then it's going to hide everything, just the water.
Yeah, that's why I was asking the question earlier to the guys on the panel about trying to maybe get up a bit higher to take the observations, because I think you're right. If you're taking them always down, I don't know, whatever, 2 foot like this or something, there's a lot that can get in the way, isn't there? Unless you've got a very calm day, like you say, and little to no swell. There's a lot to be taken into account. There's a lot of variables.
When you get a really calm day, and you get observations like this on the left, which you've agreed to me that this is a really calm day, nice beautiful sea, blue colour, but it is a shore-to-shore observation. Now, I have a bunch of about 20 images on this day from the same height, above actual sea level, with the same conditions, and it's literally shore-to-shore, shore-to-shore, right, over a distance of 18 miles. So in your model, and what the Globers in the chat would say, is that everything that we're looking at here, this lighthouse in the background and this green crane, everything here is being loomed up. It's not really there. It's a figment of your imagination. You're not really seeing it. You're not really seeing the shoreline here. This isn't there because this goes against your model. And we just say, well, we see it. And this is the difference, you see. So on a very, very clear, calm day like this, we see shore to shore. And the reason I said red pill philosophy was because he did a very similar observation to this with the same kind of conditions, with a blue sea. You had a blue sea, very flat, very, very similar to this kind of water with these little ripples on. And it was shore to shore. So, and the observation on the right just shows that, what kind of obstruction you can get with just a little wave. This isn't a 6 foot wave. This is like a 1 foot or a 2 foot wave at most. So
I guess my question would be, if, let's say, the one on the left was looming up, that background and the crane and everything, and that's being loomed up, right? Let's assume for a sec that it is. Surely if you go there on other days, you absolutely wouldn't see that, because the looming doesn't occur all the time. It's not like something that's always there, is it?
Looming doesn't occur. I've looked for looming. This post here on the left, it's got a little star on the top. So when I'm at a higher elevation and I'm looking at these buildings over it, there's a building down here, for instance, right? That's the clock tower, right? It's Barrow Town Hall. And further to the left, you've got Devonstock Hall and stuff. So from my different position off the sea wall, I'm looking down towards this, right? And behind it, I've got the buildings of Barrow. They never change the relative position, ever, between this post and the buildings behind it. Ever. They never change.
Right. Okay. So that you're saying isn't changing, so therefore it can't be looming because it's always in line with that star. Yeah.
Yeah. Well, I'm trying to find evidence of looming. Here we go. This is the same day that I took that image. So this is another image that I put up. This is the day with the blue water and the very little ripples. Shore to shore observation. All these buildings. None of these should be seen. None of these. All of these buildings here in your model are being loomed up. Even this little rock, there's a rock here on the shoreline that you can see at a higher elevation. And
quite a big rock, that black one.
Yeah, and it's directly in the line of sight of this. I think it's a medical building. There's the tower, the clock hall. Here you've got some office buildings. You scroll all the way through here. You've got Devonstock Hall. You've got the even further over, you've still got land here. Can you see this land It's very misty and hazy, and that to me just is unclear. But you can make it out. But these buildings are very visible, right?
They are. I mean, those buildings are definitely there. Yep, I can see them.
And they're all in proportion. They're exactly the way where they should be, and it's a shore-to-shore observation.
Right. Okay. I guess I'd have to look into it and look at the Google Maps and that. I mean, I think those kind of things probably are reasonably interesting to look at. How about where you see, the boats supposedly going over the curve and they disappear, like the one that they looked at the other day, where it was a blue boat on the bottom, it was white on top. It seemed like half of it was missing. It did look very convincing to me. What?
One sec. So if I bring up this image here, so here we've got. Why has that come up there? I don't want it to go on that one. I want it to open with photos. Here we go. So, what do you think you're seeing here? I've called this piranha boat. Do you think it looks like a piranha?
Yeah, I mean, it's some kind of refraction going on, isn't there? I guess at the bottom, and it looks like it's inverting that whole layer across, doesn't it? So one is either going up or one is going down, I guess.
What would you? What, Chemo? Are you still here, or has he dropped?
No, I think he went off. He said bye-bye in the chat.
Oh, right, I've missed it. Right, okay. So, well, Gleam, you can see this image. What do you think this is an inferior mirage or is it looming? Which one is it?
Okay, it's a mirage. It's definitely a mirage. I don't see looming going on. I see from there to the water edge, let's say, is a complete mirage. It's a mirroring of the water surface. However, I mean, obviously refraction is involved, but I think that has got to do with the critical angle of light, where the heat is actually making it so it's mirroring the sky or mirroring upwards. And that, to be honest, I reckon is the last 0.02 degrees in your camera when you zoom in. But that could be Jack Daniels.
Can I ask a question real quick?
Of course you can.
Can we maybe get a consensus real quick on what looming means? Are we all comfortable with what that term implies?
Bringing something up over the curve, as I understand it, if I do.
Okay, so that was Gleam, right? So Toady, what's your...
I'm comfortable with that definition that Gleam gave. It's bringing something up that you shouldn't be seeing from theoretically behind the horizon or the curve, and making you see it. Yep.
Okay, so what do you think, where do you think the bottom of the boat is?
Well, that's a good question. I don't know how deep that boat is. I guess you've got somewhere else a picture of this boat. It may even be below the water line, I suppose, on this picture, because it looks like could be quite a tall boat. But certainly a lot of the boat is being blocked out by that mirage, let's call it, if we want to call it a mirage. And the boat is probably below the sea. The bottom of the boat, if you took it in proportion that could be stretched, is probably below the water level.
Let me see if I can bring up the image.
I'll go all out and I'll say that it's elongated as well.
What you mean horizontally?
Yeah, that looks out of proportion. I don't know whether it's Jack Daniels again. Could be, but
it could be. But I wouldn't like to put my life on it. Yeah.
There is also vertical compression as well as horizontal compression downwards, as well as squashing it up left to right, which is exactly what your eyes do, exactly what perspective does, but creates an illusionary version of it in front of your illusionary version of it. Double illusion.
So you think, Glenn, that there might be looming and a miraging effect?
The mirror? No, not looming. Not right. Looming. Looming. I know happens. I definitely know happens, but in as much as I think, in order for that to reflect it must have something to reflect from. Yeah? So there must be something, a solid surface there for that to be a reflection on it. Similar to how a mirror would be, a physical mirror.
Yeah, that's where I come in, and that's where I'm going to postulate that it is the air, it's the ether band that's doing the.
Yeah, I do agree. There must be something there, density of something, air, presumably, near to the water that is causing that effect. I'm going to call it effect at the moment. I'm picking my words carefully. That miraging effect needs to be due to the density of the air. And if you want to call it an ether band, I mean, that's fine. I don't particularly like the term, but it's definitely causing that effect there, isn't it? We all agree there's an effect going on. The boat doesn't look like that, right? We all agree the boat does not look like that.
Yeah. The core thing that I see, I only joined Jose's very late on in the actual stream, but I see Al K present something where some guys done some mist, whatever gas it was, and it allowed you to see over the actual pipe. Yeah,
that was really interesting. Yeah.
Now, if you understood that, the actual top part, the top color part, was compressed.
It was. That's why we moved on to the other image. So we'll just talk through that while Randy's looking for his bit. As you say, they poured, I think it was liquid nitrogen onto the top part of a barrel. And what it did is, I don't know whether Travis saw that as well, whether you saw it as well, Travis. It poured up the red part so you could see it over the top of the barrel. So it definitely moved, the red bit up. And it seemed to magnify it a little bit outwards as well, like you said, Gleam, earlier. Yeah, it seemed to be horizontal and vertical slightly. Not a lot, but slightly. Yeah. And then what it also did is it compressed, didn't move the top bit up, because there wasn't enough of it, Rumpus said. But it definitely did compress the top sort of green bit or blue bit, whichever colour you wanted to call the top bit of plasticine, was also compressed. It was a fascinating, experiment. Because it did two of the things we see, wasn't it? We see things pulled up and we see things compressed.
Right, so here's what I would like to see with that same demonstration. Is I would like to see the reverse side of where he had his object, and then I would like to see him move it in proximity and into distance and show us. I don't think that it demonstrates anything that we could take into the real world and say that it's analogous to what we see, because there's too many variables that aren't what we have in our real world observations. But nonetheless, my point would be, show me what you're doing at distance, because the one thing that looming does, the one thing that makes looming super, gentlemen, thing that makes it super is that it looms at 5 miles and 10 miles and 20 miles and 50 miles. And you always see exactly everything that you're supposed to see, no matter what the distance is.
How do you mean you see everything you're supposed to see, no matter what the distance? I don't
okay,
understand
so like Ranty showed us the landscape that he has across the water, bordering the furnace, right? Mm. So that is like at 18 miles, and we see everything that's there. Mm. Well, if he had something that was at 30 miles away, we wouldn't just see the tippy tops of it. Like it's still over the curve, and looming just couldn't pull it all up. Looming tried, it was just squeezing, tried, and all I could do was just get the tips. No, we would see everything. So it doesn't matter what the distance is, we always see what's there.
Right, that's an interesting point, but isn't that based on the observer looking across? Because if we do take, and I do think you can look for analogies in the liquid nitrogen being poured on top of the bottle, because I think it was very interesting. By the way, I wish he'd had something that was sort of more like a ruler with colours on it or something, because the plasticine was a little bit, it's hard to tell the widths and so forth. Okay, we've got a picture now of the boat.
So, it's about the best one I could find.
Okay, that's good, because we can see that the effect is starting well above the blue hull.
Well, not too sure, because
all right.
Well, it's just about the.
Shall I say why I'm saying that?
Well, you can see the front of the boat sticking out here, which means we're seeing at least to the. Let me just increase the height of this so you guys can see. So we're definitely seeing part of the front of the boat, which means we're seeing, I don't know, maybe the white part of it. and then the blue part, the hull, is all basically hidden. So
To go back to the other picture, I'll
maybe
explain.
just a little
Yeah.
bit of the blue at the front.
All right, I'll tell you why I'm saying that. If we look at the emblem on the side,
Yep.
can you see it seems to be? I mean, because it could be what do you call it, miraging, and then it could also be having another effect as well. Yeah, because that emblem seems to be, it's definitely hitting the emblem. Do you see what I mean? Because the emblem looks like a sort of an 8.
Yep.
Yeah.
But we've
So
also
I
got
think
this gap
keyhole.
between the two, haven't we? The mirror, the image actually starts here. You get a little bit
but
of
that's not-
stretch. Yeah, what happens is you get a tiny bit of
Ah.
stretching just above the inferior mirage. Then you get the clear inferior mirage. There's always a little bit of stretch down and
Yeah.
pulling down that seems to happen. I think the inferior mirage is happening just just about here, and you're just getting a front of the part of the boat, and then the rest of it's all being stretched down, which is why you get it. It's all ziggity zaggedy like so. It's all ziggity zaggedy here, ziggity zaggedy here, where it's being stretched.
It'll be constantly changing, won't it? So
Yes.
you would have just snapped it at that time, and then sometime it'll be a bit blurred that way. But there is that definite line, as you say, which is like the same line.
Yeah, it's
But
very interesting. Yeah, you've got the
everything's
line, and
white.
then you've got that stretching, haven't you, as well? So it almost looks like there could be two effects.
If you can see that the windows, let's say the very small windows, there's a very dark shade on the front of it. You understand? So there's 6 main windows, and then you've got all those little windows around them. If you look on the blurry one, then you see they're in dark shade. Now, if you look nearer the sea is also in a dark shade. So it's as if it is picking something up through it, but it is getting blurred out or mirrored or whatever, tripped.
But what's interesting here is the point I'm trying to make is that all this part from here to here is the depth of the hull.
Yeah,
Right. So
that's it.
whatever's behind whatever the reason we can't see this inferior mirage or the bottom of the boat. I asked you before, why can't we see the bottom of the boat? And I wanted you to say, well, it's behind the inferior mirage. And essentially this is what it's doing. It's blocking out the bottom of the boat. This inferior mirage is absolutely covering up the bottom of the boat.
Agreed. It is definitely. That's why we can't see the bottom. We can't see the hull, because I thought the boat would be deeper. I thought it was one of those Stena ferries or whatever, the deeper ones. Yeah, but you're right. It probably isn't much below the water at all, if at all. Do you see what I mean?
Yeah.
It looks proportionate from how you've matched that up. So I don't think there's much. What am I saying? There isn't much missing at the bottom, other than that mirage is covering up the hull.
Now, when I first showed this kind of stuff last year and the start of last year, people were saying this is where the Earth curve starts, where this fold line is in the middle. This is where the Earth curve starts, and it was always a globe Earth proof.
Yep.
That's why we don't see the bottom of the hull. The bottom of the hull's missing to Earth curvature. That's all I ever heard. That's now changed, thankfully. People are now fully aware that this inferior mirage isn't actually Earth curve. We now know that it's atmospheric, and I've got plenty of information to prove that. I've got many videos up that show this exact effect happening at elevations that you should just have a clear line of sight. For instance, looking at the buildings of Barrow from a high elevation of approximately 50 feet, looking at land masses just some 12 miles away, things like that. We've got this massive inferior mirage hiding 50 foot of the land. Well, you should have a clear line of sight to it and things like this, and we get an inferior mirage that's happening. Other times when we've got a deeper inferior mirage, I've seen a boat that's just been 7 miles away, as big as this, just 7 miles away from an elevation of 12 feet. I did a video on it. I was actually filming it and went up different steps. I was 12 feet above sea level, and 3/4 of the boat was hidden. 3/4 of the boat was missing to an inferior mirage. Clearly atmospheric, because I should have had direct line of sight to that boat. There should have been no obstruction whatsoever, and yet most of the boat was hidden behind an inferior mirage. That's another video on my channel. So these repeated observations and demonstrations of this effect have shown that what we're looking at here, when we look at this inferior mirage, we're just seeing an inferior mirage, and this inferior mirage is blockage, but it's not Earth curvature. It's Definitely not Earth
So
curvature.
let me jump in real quick.
Of course, yeah.
So my observations are I would say identical to Ranty's. Except I have shorter distances, and the way that I have thought through this is that I am seeing these phenomena at shorter distances. So if I have a sailboat like I had today, 5.85 miles away, and all I could see were the sails, I could not see the deck, I couldn't see the hull, but my friends who were on the other side of the bay, that boat was 100 yards offshore. So that boat was 5.84 miles away from me, but I couldn't see the bottom of the boat, right? So when we have that, that's not Earth curve blocking the entirety of the ship at 5 miles away. But we do see the inferior mirage. So the logical thing to understand is that if you simply move that object into the distance and you have the same kind of observation where there's an inferior mirage, that's the explanation. And that alone, there's nothing else to explain. No matter what the distance is, you're always going to have either a direct line of sight and it's clear and you can see the boat, no problem. But when you don't see the boat, the only explanation is it's atmospheric.
Okay, I'm not convinced by that. Just to be clear.
Well,
yeah,
I can show you a video.
Sorry, not that picture. What Travis has just said, that it's always atmospheric, because, as I say, the one that we looked at before, Travis, on Jose's, I'd need to understand how that atmospheric effect was moving the top of the boat downwards and removing the whole of the hull. Yeah, in that image. But I'm not saying they're not atmospheric effects. Clearly there are. I mean, it would be silly for anyone to say that there are not atmospheric effects. Clearly they're there.
Sure.
This is the thing, though. Yeah, I, from an outsider looking in on the scene, though, this is the thing that where a lot of globe earthers actually say, right, there's something hidden equals curve, and that's it. That's as far as they go. They don't even bother about to count any atmospheric effects, any wave height, any swell. That's it. It's Earth's curve. Look, it's going over the curve.
If I pause this video...
Well, it's clearly more complicated than that. I don't
exactly.
know if it says that now, but it is clearly more complicated than that, isn't it? It would be unfair to say otherwise. It is definitely more complicated than that, isn't it?
Well,
as we've seen. Yeah.
I'll tell you a very brief story about how to blag someone, how to trick someone in saying that there is a curve. Bob the Science Guy, he done an analysis of Jeranism, done a view on the Monterey Bay. I think they were called sort of like flat Earth reality analysis, but they were the ones that done the mirror. I don't know whether anyone can remember that. They done a mirror.
Oh yeah, and they bounced the sun off it.
It's bounced the sun off it, and then guys, however many miles, 10 to 18 miles away, they captured it. They actually saw the direct light when they were down at the beach, flashing it down. Now, Bob the Science Guy basically found a photograph on the internet. I don't know whether you're aware, but they had two massive chimney breasts in the background, two massive chimneys, and there was a building right next to it. And Bob the Science Guy said, right, I found this photograph where there is a couple of buildings to the right hand side of these chimney breasts which are not shown in their footage. When they show their footage, hence must be covered by Earth's curve. And then when you look into it, Bob the Science Guy has actually just grabbed it randomly off of Google Images. And you trace, I spent hours literally on Google Earth down in Google Street View, and I managed to find the buildings that he was on about, and it was a post office right near where it is. But the photograph where he's downloaded randomly is actually taken from a car park, which is half the distance towards the actual chimneys, and is from a different angle, and has a 3-meter advantage because it's up in a car park before you get to the beach. So what he's actually showed everyone is basically saying, look, this cannot be a flat Earth because these buildings should be visible from where their photos were. And then if you literally go into Google Earth and bear in mind Google Earth can be crap on their elevation.
Well, they are. Numbers. It's very inaccurate.
Yeah, very, very inaccurate. But if you get the Monterey Bay guys actual footage of a square on of the chimney breast, of the flashing light of the mirror, as well as this building just to the right of it, you can actually see that the building on Google Earth, it's 10 meters above sea level. And there is 10 meters from the bottom of the building down to sea level. So the actual mathematics, it was bar about 7 mil off of 10 meters if you calculated it out per what I was seeing on the actual photograph in millimeters measured in Photoshop. And it was like, he said, no, wait there, that's Earth curve because these buildings must be hidden. And it's something exactly the same as this. Something simple where you just discount some real world event or real life phenomenon that you're seeing. Same in Soundly's footage, all his bridge, his pylons, all suffer from this exact same atmospheric effect. And everyone goes, look, it's curve. I can see curve.
If you look at this image now, do you see curvature?
You would
hard
never
to
on the
tell
horizontal.
what I can see. Yeah, there's an effect, isn't there, right above the water?
Well,
That's unusual because that buoy is there. Maybe that buoy is much closer to you. Is it on the left? That you see that orange buoy? That doesn't seem to be.
there's also some. Where are we? Let me just find them. Where they are.
You have to consider that buoy might be closer to you. But what I would say, based on the observations I've made, if you cut that mirror image in half, that's where the reflection starts, and that entire boat is hidden behind the mirage.
Well, let me just to give you some details here. So my elevation right now, from what I can recall, was 12 feet. It says it in the video, so you'll have to excuse me because I actually count it out. But it's 12 feet. The distance to this boat is just 7 miles away. Now, in where I live, they have an estuary and they have to follow a set channel. It's a very narrow, very deep area that allows these boats to come in and go from Heysham. So they have a set path every single time. So within half a mile, it's like a half a mile to a mile wide channel, right? The rest of it, they would get beached. So they have to travel up and down this channel. I was able to triangulate the boat and all these wind turbines right now in the distance, and by doing so I was able to find out exactly how far away this boat was. Now this boat was 7 miles away and my elevation is 12 feet, and this boat is almost 100 feet high to the top. Yeah.
What should the hidden be at that distance, Renty? Do you know?
I think when I did all my calculations, if I recall, so you'll have to excuse me because it's been since it was at Christmas when I did this, so what are we in now? So this is 10 months ago, so you'll have to excuse me. But when I did the calculations back then, when I figured everything out, the refracted hidden should have been 2 inches, I think, or 1 inch. It was either 1 inch or 2 inch. There should have been 1 inch or 2 inches of hidden. I think that was all it would have been. So whatever my calculations are, if I've messed them up slightly with what I'm saying right now, but I know the boat was 7 miles away. My elevation was approximately 12 feet. There should have been about 1 or 2 inches of hidden, and clearly what we're looking at here right now is at least probably 60 feet of hidden, right? There's absolutely no way. I mean, I should have had just a direct line of sight to this boat. You can actually see this in the foreground. There's this canoe. There's a guy in a canoe here.
Oh yeah. Mm-hmm.
He looks fine. But once you go past a certain distance, things start to happen. This mirror image starts to happen, and it's blocked the bottom of the boat.
So, quick question then. Again, you may not like it. If there is 60 foot of hidden, let's assume the Earth is flat, yeah, and you've got 60 foot of hidden. What's happening to the rest of it? Is it pushing the boat up? Is it pushing the sea down?
No, it's just atmospheric blockage. It's what I've said all along. I mean, guys,
Or was
here,
it not blocking the whole of the boat, that 60 foot? Or maybe that boat's very tall, is it? How high is the whole boat?
well, it's just an angle, isn't it? It's an angle that happens.
Can I ask you, Ranty? I've put it in the Skype chat, and it's the diagram saying 2 object obstruction. It's the top one before the wave height one.
In this chat right now.
Yeah, in the Skype chat. Yeah. And it's just a little diagram that I did to show
Which one's it? Which
that
one?
the one above wave height.
This one.
That's it. Yeah. And it's just basically, it is mainly to show the difference between orthographic and perspective. But if you look at the bottom bit there, if the observer, let's pretend the first green block is a small wave in between you and whatever you're looking at, and the object B is the mirage. Okay, so if you can see in the perspective view on the right hand side at the top, obviously there is a proportion of the boat hidden by that yellow block, so proportion of the red block. Now obviously the line there that you see as the horizon, and obviously the viewer eye height, that would never go above the horizon to then drop. So you've got to understand that the last two, or the last part of the horizon, is slightly dropped down, and that is the mirage band, the ether band, let's say. And that is what everything is hidden behind, aka object B if it was a solid object.
So, just to follow up with Toadie's question, you know, I'm sure you might have seen, but I've got many images of fishermen on boats where they are standing up, and you can't see the boat below their feet. And well, hold on, just real quick, just real quick, please. So I think that it at least addresses your question, right? Your question before Gleam explained his diagrams was, you know, so what's going on? Why do we see the top? Why isn't the top obstructed? And Ranty rightly answered, it's the angle. So the reason why the fisherman isn't squashed and blocked by the ether band like his boat is because he's above that particular angle of resolution that is being obstructed. So if he were to sit down, he would be gone. And I have an image of this. I'm following a boat, and you can't see anybody driving it, and then all of a sudden the guy stands up and he's there, and the boat's, you know, moving along. So it's angle.
Mm-hmm.
I'm just going to play a portion of this video, and what we have here, we have the boat in the background. So that's the back of the boat here, and there's the front of the boat. There's the two spires sticking up on it. This is at a lower elevation, so right now I'm approximately 7 or 8 feet above actual sea level, and this is the boat in the background, and this is another boat in the foreground. This is a different boat altogether. This thing here is a smaller boat, but it's a bit nearer. So let me just play the video for a second, and when I pan back through, we should get them in a direct line of sight with each other. So I'm going to be moving back. Let's try and pause it. Play, pause. There we go. So now they've moved next to each other. This boat's moving in this direction. This boat in the background is moving to the right, but they're parallaxing each other, yeah? Can you see that? We have a small boat in the foreground, a big boat in the background. Mm-hmm. Can you see
yes.
that? So if I if I take an image of that, and let me just open up, so I've just print screened that, right? So let me open up a paint program, and what I'm going to do is I'm going to drop this over here, and I want you to put the lines in for me. So what I'm going to do, let me tools, crop, whatever it is, rectangle select. Ah. Right, so let me crop this out, and I want you to put the line in for me. So if it's a curve, right, we'll find it's a curve. If it's not a curve, then we won't. So let me put a line in. So tell me where this line goes. What colour should we do it? So we're going to look for the inferior mirage on the boat in the foreground. Yeah, so this one. So can you tell me where you want me to put this line in on this boat in the foreground? So you need to go lower.
For where the inferior mirage is, yep. You need to go about halfway through that white bit, I reckon.
Right, so
keep going. Ooh, getting close. About
This reminds me of that old game Nightmare.
So about there,
About there?
but it looks different, doesn't it, on that sailboat behind? Can you see the sailboat to the right behind?
Yeah, so let me put that line in for the boat
Yeah.
behind. So tell me when I've reached that one.
Yeah, I can tell you exactly. Keep going. Keep going, keep going, keep going. Ooh, nearly, a little bit more, about there.
About there. Right,
Yep.
so what does that tell you? Does it tell you that is there two Earth curves here? Because if the inferior mirage is where the curve of the Earth is, right? How come we've got two lines?
So, is it a well-held idea that the inferior mirage is always where the curve of the Earth is? I don't.
It used to be, yeah. It used to be when this blockage. So when we're looking at these boats and we're seeing the hulls of the boats missing, right? It used to be obstruction
Oh, due to curve.
due to curvature, right?
Okay, right. I don't think that's I certainly don't think that's correct.
So
Well, it's ever since
Evidence by
Metabunk-
this photo. Yeah.
ever since Metabunk put up there, please note, not suitable for use over water.
But this image perfectly demonstrates, and I know Jose's got a bunch of these too, and Red Pill Philosophy, everybody started doing this now, which is great, because you have these different boats at different different distances, all showing a different relative height to where the inferior mirage is. Now, that shows that the plane, what we would say is the plane is just extending, and that these aren't actually, this isn't actually the hump of the Earth. If this was the hump of the Earth in the foreground, right, how come there's a hump of the Earth behind it that's higher up?
Yeah, well, it's very unlikely, isn't it? How about some of the pictures that you've got, Randy, though, where you've got a boat that really does look like it's disappearing over the curve? Because these ones, I agree with you. Yeah, absolutely. There's effects going on here that may or may not be related to curvature, but it's certainly not simplistic. But I've definitely seen ones from you where it looks like a bit like the picture I put in the chat there. This is obviously I did that at small distance, which shows a guy that looks like his canoe is underwater, right? And it's actually just a swell, yeah? If you look at the chat, right? But a picture like that, but obviously at a distance. Yeah, I don't have one at distance because I've not done those observations. It'd be good for you to break down one of them for me.
Well, why don't I bring up my...
So basically,
Go ahead.
like, so basically, Toady, I think what you're asking for, because we have an inferior mirage, and what you're asking for is an image where there is no mirage, and you can only see the boat, the top of the boat touching the water line, right?
Yeah, and that's
You're
one
asking
like
for.
the one we looked at from Al-Qaeda the other day, Travis, because they're the ones that trouble me the most. If you're trying to convince me there's a flat Earth, I have yeah, like that.
Right. So here's my response to that. So you have in the image that Ranty was just showing, you have an inferior mirage, and we can be comfortable with postulating that it's the mirage that's blocking the boat. I suppose, as a result of ignorance, I would say that we have to understand that the image that doesn't have an inferior mirage and you can only see the top of the boat, that's another kind of mirage that if it hasn't been classified, it needs to be, because it's still, and it's different. So like, it's not a superior mirage, right? A superior mirage is different than an inferior mirage, but they're both mirages, and they both are actually blocking certain things that are in the distance. And the same with the Fata Morgana. It's a different kind of mirage, but it is obstruction. It is obstruction. So what I'm suggesting here with a boat, and I have images of these things, so I'm not afraid to talk about it because I've caught everything. The reason why we can't see the rest of the boat is because it's a mirage.
All right,
it's the atmosphere that's blocking it.
Can we have a look at the one that Ranty put up? Let's look at that and take me through the explanation of that.
Okay,
Is,
so
is this video, by the way, or a still photo? That'd be good to understand as well.
this is actually a video, and it's one of my more famous videos. It's one that Conspiracy Cats has referenced many a time, and it's actually one. It's probably the one that people always refer back to when they're talking about Ranty shows boats going over the curvature of the Earth, right?
Yeah.
So
You're the best globe Earth, whatever, prover or whatever, all that stuff they say.
yeah, exactly. So this
Ah.
this is the image. This is the image. So it's the same boat.
Yeah.
It's the same boat. It's just going away. If we move the video slightly forward,
But there is an effect there. I can see that writing on the side. There was definitely an effect of some sort.
indeed there is.
Right,
There's
so-
an inferior mirage on the whole boat. Now, you can clearly see this down here. You'll see it much further on. If I let me get to a point where it's really easy to see, because here we go. Because Conspiracy Cat seems to ignore this. Can you see an inferior mirage here?
Where's here?
Yes.
Well,
I can-
anywhere.
Yes.
Well, I can see there's a lot of.
Yes.
I mean, there's a lot of waving of stuff. I mean, look, there's those bent lines. In fact,
Okay.
Yeah.
Can you see an
oh,
inferior
those
mirage?
turbines are
Yeah,
there.
the turbines.
Can
Yeah,
you
they're
can you-
turbines.
Can you see an inferior mirage
Yes.
on this
I
boat?
can hear. Yeah, on that one I can. Yeah,
So,
Halfway down the yellow bit.
so
yeah, that's right.
by process of elimination, what I've walked you through on these set of images before, where do you think the hull is on the boat? Why can't we see the hull?
Well, I don't know how big this boat is, but this one looks like it could be under the water. I don't know how tall this boat is because I haven't got a reference picture.
It's the same
But it would-
boat. It's the same boat that you was been looking at.
Oh, is it
before,
the
yeah.
same one as the other one?
Yeah, the one that we looked at first, and you said, "Oh, the hull on it."
Yeah. Okay. Yeah, there's a flat hull, isn't it? It's not that deep, that hull. Don't know. I'd really like to see something proportionate next to it. It's hard to judge, isn't it? On this, could be underwater, but could be obstructed by that mirage.
Can I throw a curveball in there?
What about here?
And definitely there.
And what about
Exactly.
if you look at the
Sorry, definitely what there? Sorry, what's definitely there?
That's the
inferior
mirror line.
mirage? Yeah, here.
Probably. Yeah, hard to tell because of whatever is being inverted.
It's equal. It's equal each side. If you can see it's a mirror, he's got just the same amount of white above the darkness than there is at the bottom.
So that's the one I find difficult there, where you've just played that there. There's a bit of swell there, but I'd be surprised if whatever that inversion is accounting for disappearing the whole of the boat from what we saw earlier. That
Okay.
really looks like it's disappearing to me.
Well, you know that the boat doesn't have any white parts on its hull,
That's right. It doesn't at the bottom.
right?
Yep.
So this is the back of the boat where they load the boats in, where they load the cars into, and it's all blue. It's all
Oh, right.
blue at the back, right? All blue. So how come we got this white?
Well, that is
underneath?
definitely, from coming down from above, isn't it?
It's an inferior mirage, right where my cursor is. Yeah, right where my cursor is. Now, that's the same height as the hull. Literally, what you're looking at there, proportionally, you can take an image of this boat, the back of the boat here, the top of the boat here, all the way down to this part of the boat here. And when you place my cursor here, you could place the hull and the rest of the boat behind that inferior mirage, and it would all be proportional. There would be nothing hidden. It would just be hidden behind the inferior mirage.
It'd be good to see that. Yeah, it'd be good to see that. Yeah.
Well,
I mean, not now because you probably haven't got time, right? But
But
it would
you
be
are
good to see
seeing it.
that. Well, what I mean is, sorry, getting another image which is not with the miraging effect on to see it, because I think the further the boat goes away, the more it looks to me like it is going over the curve. Actually, we can find out. Just scroll on a bit more because presumably the boat's moving away from you, Auntie.
yeah.
And then if that white bit disappears,
Well,
yeah,
why would the white?
like-
Hang on, wait a minute. It's moving
Okay.
away. It's moving
Yeah.
away. So let me bring up Gleam's image again. Gleam had an image that he put up before. Let's see if I can. It might still be on Skype actually. So here we have this angle. Here we have an angle. I think that's the image I'm trying to portray, but it bounces, in my opinion. Not quite exactly the same as this, but what happens is the boat's getting smaller as it goes away. So what happens when it gets smaller? So way back here when we were looking at the boat, when you said, right, hang on, let me get it where it's got the white part.
well, there's more white, isn't there? Which is odd. I wouldn't.
Well,
that's
no,
in-
not really,
yeah.
not really.
Well, for me,
So-
that's
well,
counterintuitive.
Yeah, okay. So
I'm obviously not understanding it properly because I would have expected the white line to disappear. Hang on, I'm just trying to think
hang
about
on,
this.
wait a minute. So
Oh,
I'll take you
I'm
back
waiting.
to I'll take you back to this image, right?
I'm waiting.
Take
Don't
you
worry.
back to this image. So this boat is nearer, and this boat is further away. Now the
Yep.
boat the boat that's further away, the inferior mirage is higher up the boat.
The boat that is further
If-
away, the inferior mirage is higher up the boat.
Yeah, it's
Okay.
higher. It's higher up. So if
Yep.
we put this little boat in the foreground, and we say, sail away, little boat, go away, little boat, I don't want you here.
Oh, I see. It's moving into a higher mirage area.
So as the boat moves away, the inferior mirage is getting higher and higher and higher up this boat till eventually all of the boat is hidden behind the inferior mirage. Now, the same with this boat here. It's going further away from me. It's going directly away from me, moving away. It's getting
No, see, in my head,
inferior mirage.
Let me explain where it might be going wrong. In my head, this inferior mirage layer, this density layer, is in my head, and this is where I think my conception is wrong at the moment. It's like imagine a rolled up tube, and it's just sort of at the point where you see the effect. It's like a rolled up tube, but I don't think it is. I think it's more like a sort of a squashed donut or something, or a coin. I think it's an area. Yeah, it's more like an area that runs through. I'm imagining it as like a rolling tube. Yeah, but it isn't. I think it obviously is a layer more.
So let's do it in.
Randy, go ahead.
I do see your point. Yeah.
So let's.
I want to.
Yeah, I'll round up quickly, and then I'll let you guys have a go.
Okay, thanks. Thank you.
Okay, so let me just put this, do a line now. So we're going to do this in Muppet Vision. Okay, so what we're going to do is we're going to put, this boat in the foreground. We're going to do it in red, right? So let's get it in red. So we're going to put this boat, let's say here. So there's boat number 1. This is Muppet Vision from the side. This is my observer point down here. So here's me observing. I'm looking at this boat here, and in the background we've got the big boat behind it, yeah? So now we've got 3 reference points, yeah? This boat here is this boat. This boat here is the big one in the background, right? But what we're going to do next is we're going to do it like so. This is Muppet Vision, right? So it's an angle, what we're saying. So this boat in the foreground, as it moves further away, it goes higher up the boat. So if we get a red line in, and we put this in here and we match it up. So here's the boat as it stands. Let me scroll in a bit. And what I'm going to do is I'm going to move the boat further away. So as I move the boat further away and further away, look what happens.
It's moving more and more up the boat. Yep.
Moves up the boat.
Completely concur with that. I get that now.
Okay.
But I always think of it as a roll, like a tube, like a sideways as a circle, but it's not, is it? It's a layer.
It's like a layer, a mirrored water layer, as Pete Shea would say. And as it moves closer towards you, obviously it goes, you start to see more of the boat. Now this is evidenced in these images here. Now bringing back the image that you were talking about, and you said how come it's disappearing up the boat, and you're seeing less of it, and all the white disappears like here, like it's almost disappearing here. Right?
Yeah, right, like there, yeah.
But if you think this boat is further away, its angular size is also smaller, right?
Which it is, yeah.
Okay, and we've got a smaller boat further away. The inferior mirage is creeping up the height of the boat. We've got these little waves in the foreground are even causing issues. You can see they're almost the height of this chimney when you actually play the video.
So, quick question: between those frames you moved from when we first saw it to there, is that the line, wherever we put the line, is that moving up the boat?
Right
just
here,
out of interest.
That's the inferior mirage there, right there.
Right, yeah, okay. And can we go back and just see where it was? Because I'd say that is about, I could measure it on your screen. I'll put my cursor where it is.
I would say the boat is probably a third. Well, it's hard to. I'm doing this freehand, so it's unlikely it's going to be in the same place. But the boat itself is probably around about a quarter of a mile further away, so not a huge distance further away.
And if you just go back and just see where the line was, okay, about there. Yeah, it'd be nice to measure to see if it is moving up the boat. You just go back to the much earlier on, just so I can see where the line was. Sorry. You can, Travis. Could you just go back a sec, Ranty, just to
where? Sorry.
16 minutes. I don't know, about 8 minutes or something. As long as that's the back of the boat, yeah. Just to see where the inferior mirage is.
Yeah, that's what I was going to ask, Ranty. Is there any way that you could put a line on this video, like go back where you could see the Stella line words?
There we go.
Even going farther back.
There's the inferior mirage.
I think it is moving up. I think I do agree with you. It's moving up the boat, isn't it? Yeah, I agree. It appears to be from what we've seen. Obviously, I'd like to do some more analysis. It does look like it's moving up. I agree.
Now, the good thing about this particular image here is you can see that the whole back of the boat is blue. And we get this reflection down underneath it. So it's clearly an inferior mirage that's happening on
it's
the boat.
reflecting blue there, isn't it? Yeah.
And what's like I say, what's really one of these points is that Conspiracy Cats never, ever admits that there's an inferior mirage here. And the narrative that's being punted is that I film a boat going over the horizon. That's the narrative that's punted, and it's very disingenuous when you consider the body of work and the amount of effort and time I've put in to understand this stuff. And just by walking through this with you right now, you've been able to agree that, yeah, we're seeing an inferior mirage, and we can see that things are blocked out by inferior mirages. This is obviously what's happening. And
just to be clear, I'm not making any claim about whether it's going over the horizon or not, because it might it might still be. But I am concurring. The inferior mirage is there. It is blocking stuff, and it is moving up the boat.
Thank you. But just to
otherwise, I'll get
say,
crucified otherwise. So I just want to be very careful what I'm saying.
Just to carte blanche say, Ranty films a boat going over the curvature of the Earth and say that this is proof of the boat going over the curvature of the Earth is very disingenuous to the amount of work that I've put into this, explaining this kind of observations. It doesn't help when we're all trying to find the truth at the end of the day, and this sort of research needs to be discussed, it needs to be showed, and it needs to be showed in a way that everybody understands what they're seeing, instead of just believing what one person's punting and other people then creating a narrative that goes along with that is totally against what I have actually shown, right? And that's what this is the whole point of this. So with that, I'm going to let the plain truth. You wanted something to say, and Gleam, you two guys, do you want to carry on for a little bit? I'm just going to go and have a cigarette.
Cool, you go ahead, plain truth.
Okay, I'm sorry. I was just talking to somebody, so I didn't hear what you said, Ranty. Can you repeat it?
I said I'm going to take a little break for a minute if you guys want to carry on for the next 5 or 10 minutes.
Okay, I'm not sure I have anything right now off the top of my head. I mean, but this is, stuff that I've captured. Go ahead, William.
Yeah, I do, Ranty. Could you just, before you go for the SIG, could you just click up the latest picture that I've just put up in Skype?
Yeah, sure.
Yeah, just to show Toady. Toady, you must remember these. Mick West done it. Karen. Karen B.
Is it a video? Is it a video or an image you want?
It's the image above the video. I've given you the link to the video as well as a screenshot of it.
Oh right, okay, I see. This image?
Yeah, exactly, exactly this. And everyone should know the Action Lab. I love watching his videos. He just does.
I know him quite well. Yeah,
he's funny. But he done exactly what Mick West done and Karen B done, where they filled up a tank with a gradient of sugar water and left it overnight, and that leaves a gradient. And aside from the ether band, because we obviously know that the temperature inversion causes the miraging. But not only that, while you're looking through a gradient medium, there are also optical effects which bend the light anyway, which is going right the way back to the looming aspect, where what he shows in this video, and I don't want Ranty to get any ban, that's why I took the screenshot. But if anyone wants to search it up, he says crazy material that can make at home that actually bends light. And it is just basically this water with sugar, mix it up, let it settle overnight, and you'll get a density gradient. And all he's put in there is a ball bearing. And all he's done is he started, and if you look from around about the 9-minute marker, he starts looking down in on his vacuum chamber. He uses it for everything. He's filled it up with water, and he's looking down in on it, and it looks perfectly square. It looks.
So are we looking from the top now?
No, we are looking from the side, as if that's his unit in the background. So that's his kitchen unit, let's say. Right. Yeah. So he's got the let's say fish tank, which is a vacuum tank, sat on there. It's full with water. He's dropped a ball bearing in the other side, and he's now dropping down with his camera from the top down to the side. And if you can see there blatantly, without any camera trick, without anything other than that gradient being there, that that ball bearing has turned from an actual circle or sphere to an actual squashed. Now, if you can see that I wouldn't say it's perfectly primary evidence or anything like that, but that actually is how the sun looks like when it's setting in real life. Okay, so as in it squashes like that. That's how it sets on that thin band that we call the convergence point, where the sky meets the horizon or the floor.
I normally see the sun going down. If you take a solar filter, it does seem to disappear generally behind an edge. I mean, it may get a little bit squashed. I'd need to see some photos of that, though, Gleam, too. Because I think you're making a three logical steps here. Do you see what I mean? We don't have a medium that's made out of sugar water at the moment in the atmosphere. And yeah, I'd need to see more evidence of this, because also the sun then disappears, which I don't quite understand if the Earth was not round. Are you saying the Earth's flat at the moment, Gleam? I'm always confused about where you stand on it.
No, I am on no side. I'm just saying that there are mechanisms to explain both models, because both models have been built from the same observed reality. So to basically understand the flat Earth on how things set, how things actually work on the flat Earth, and using perspective instead of actual curvature, geometric curvature, then you start to understand, you can explain it. Whether you can prove it or not is a completely separate matter, but the difference in the scene I see is there's a lot of globe earthers out there saying, you can't do this, you haven't got a working model for this, or you haven't got a model for this. And I'm not saying that you just said that a minute ago, but there are models for the flat Earth. Flat Earth is used in science and as advanced science because it's made it easier with approximations. So the flat Earth model works. There is working flat Earth models that flat earthers have made. It's just people don't understand how, and that's the thing. And this is the explanation, or an explanation. I wouldn't say, this is the all singing answer. You must believe this, but it's a demonstration in someone's kitchen that you can see how a sun would squash without the need for any curvature. And if you look in the side chat in the Skype, you'll see keyhole-looking suns where the same band is.
Yeah, I've just had a look at the two pictures.
Yeah,
there is a band.
more.
There is a band. Yeah, there is that band that we've seen with the boats.
There are more extreme versions. That is a standard. There are more very extreme versions, which makes the sun look like a sausage almost. And bear in mind as well that actual any picture from the sun on the horizon is actually a complete illusion anyway, on a globe Earth, that is, because the sun has already set. As soon as the bottom part of the solar disk touches the horizon, in reality, that physical sun is already 100% set behind the horizon on the globe Earth model. What you're seeing is actually the delayed light, or the apparent sun, it's called. If you pull up the latest one in Skype, you'll see that fatness. And again, I'm not saying that this is definitely the mechanism, but if you can show it, if you can demonstrate that, there is science to back it, then I don't understand why globe earthers are not accounting for this and then saying, no, flat earthers, we've accounted for everything that you've said it is, and it isn't that.
Well, the issue I tend to have, Gleam, is if you think this is good evidence, I don't think it is, by the way. Yeah, and I'm not a rude person, so I won't say go to why I don't think it's very good evidence. But if you think this is convincing evidence, right, that you've got a sun that's on a flat Earth and it's just being squashed, right, disappearing behind a banding layer or whatever the effect is, I mean, I would argue that other people can see that sun further along the Earth.
Sure.
But really, I get back to you need to do your trip, and you need to head as east as you can using dead reckoning. And I was trying to come up with some other methods the other day, and just keep going east to see if you can reach the wall or the edge, whatever we want to call it, the Antarctic wall. I think rather than heading towards Antarctica. Yeah, that's what you need to do.
Yeah,
right?
if you go east though, that you're using a compass, and the compass is always pointing north, so you're just going to be hula hooping.
Well, that's why I say I think you go as east as far as you can to sort of the 59th parallel, and then you use some kind of dead reckoning method, because I agree, you might just go in a circle. I mean, I would argue that I could show and plot a set of aircraft flights all the way around the globe, right? Just like, Blue Marble did. Because the difficulty I have, Gleam, is if I really believed it, if I looked at this and it convinced me, which it doesn't, I would need to go and test that.
Yeah,
So it would be, huge. It would be huge. It would, almost be as big as religion for me.
yeah.
Not quite, but let's say the two are similar. But it would mean that there are some big secrets to look into.
Yeah, the core thing on my point of view is it takes me back, and I think it was an Aristotle quote, which was saying the ability to entertain a thought experiment without actually adopting the belief of it. And that's what I think I did. I looked at the flat earth and I thought, okay, I don't have to believe this. I look at it and yeah, it's a conspiracy. I like listening, I like watching, I like looking at the scene. But let's entertain it. Let's believe it's possible, and then start from an outset of, okay, how would this work? Or how could this work? Is there anything possible that explains this? And everything that I found on the flat earth, there is a possible explanation. And it's not that you have to adopt the belief. It's not that you have to become a flat earther. It's you have to understand the difficulty it would take to say, yeah, this is definitely a globe and I can falsify it using the flat earth model.
So what I would argue is that you probably haven't looked super hard at things, because the things that I've looked at, things that I definitely can talk very knowledgeably about, like signals from satellites, actual signals from satellites, GPS and maps. I've just looked at laser ranging interferometry, which is a really fascinating thing. I've looked at results. I've contacted a scientist from the Apollo labs, and he sent me his some of his results and his sort of deck that he uses to explain it to normal people, as it were, with pictures of the experiments they're doing and the 5 different observatories, and I'll be putting that out shortly on Jose's channel. For me, that's very, very strong evidence. That guy is definitely getting a laser and he's bouncing it off something. And those results look pretty conclusive that it's a mirror that was left by the Apollo missions, right? So, this is what I mean about testing things. I've got some areas which are, for me, very, very strong evidence. Looking at a picture of a squashed sun, I don't find very convincing. And that's why I'd prompt you, because I agree with you, it's nice to have an intellectual exercise to experiment on these things, because I like doing that too. It's nice to assume, right, what if it was true? What would that mean? What can we test? But yeah, I mean, I find this very weak. This to me is extremely weak.
Let me step up the gear then. Let me step up the gear and say, could any of the current physics be incorrect in as much as your radio wave measurement, speed of light, etc.?
Well, hang on. Before we go on to that, guys,
Oh,
I am
let's
actually
not go deep.
Yeah, I'm presenting.
Wanting to go to bed tonight at some point, I presume.
Well, I'm presenting a really beautiful image of a sunset. Can you guys see this?
Yep.
Okay. What Gleam was saying here is that as the sun goes further away, it hides behind. You get this increased magnification of some kind of apparent sun. Yeah. So on this image, can you see where the real sun is? Because I can clearly see where the real sun is. And obviously we've got a bloated secondary
Yeah, I mean, I think the
image.
top looks like it's the real sun just above the clouds, actually, I'd probably argue.
Yep.
Yeah, and if I put that curve down, and then there's this sort of squashed, bloated thing. Yep.
Yeah, so
That's what I would conclude. From what I've seen, I don't know. I've not seen enough of these type of sunsets, but that would be my guesstimate at the moment.
I would agree completely. And what we see happening is the sun going further and further away. So if this is the real sun going further away, and what we're getting here is the remnants of the light of the sun hitting the atmosphere and bloating it up. As the sun goes further and further away, it's going to get lower due to perspective. Obviously, it's going to look like it's saying the same as if you're looking at a lamppost in the distance. It's going to get smaller, or a boat. It's going to get nearer to the horizon. So this real sun, which is clearly visible at the top here, is going further away, and it is being hidden by the light that it's shining off the atmosphere, creating this apparent sun here. And when you see the sun's moving further away, and this is dropping and dropping and dropping, the light's dropping, the sun's going further away. Would you agree?
I would agree that the Earth is turning. And yeah, you know, you think the sun is, I don't know, this is what I don't understand, what you think is actually happening with that sun, because, you know, that sun for me is going behind a horizon. There are some effects on the horizon that's squashing that sun. The sun is setting, yeah, because the Earth is obviously turning, and that's how we get day and night. I'm very happy with that. It will come back around the bottom in 12 hours, and I'll get a sunrise again. I can't even possibly imagine in my head what you guys think is actually happening. Is it a linear sun just traveling away along a...
Can I step in?
Let me jump in just real quick,
Just
as a side comic relief. So when you say it goes around the bottom and it's going to come around, so you're telling me that people on the other side of the Earth are standing upside down right now. That's what you believe?
Yeah, I mean, you know, the trouble is how we try to describe things. You know what I mean. I don't think that it's actually traveling around the bottom. I think we are, of course, traveling around the sun. I don't actually think the sun's traveling around us.
Can I ask a deadly serious question to you, Toady?
Yep.
If I said to you, okay, and I haven't done this, somebody else has though. Yeah, if I said to you, okay, what I've done is I got, and I'm just going to talk in third person here because I'm representing the other person, even though I've got no connections to him, albeit I'm a friend on Facebook and I subscribe to his YouTube channel. I've got 3ds Studio Max, which is basically a 3D software. I don't know whether you're aware of that.
Mm-hmm.
Can you load that up, please, Ranty? The video that I've just posted up there. I've got 3ds Studio Max. I've put in the dimensions of the flat Earth as I think it is. I've used, however, a AE map, a normal AE map, which we all know is wrong. However, I've used that as the base, just material for the bottom in my studio model. And what I've done is I've got JPL data, you know, the Jet Propulsion Labs data of where all the planets are. And what I've actually done is I've designed a flat Earth model which actually projects all of those exact points of where the planets are, but on a flat Earth model. Now, what I can do with this flat Earth model is not only can I take a God view and look at all the planets from above and their motions over years and years of predictions from this JPL data, but what I can also do is I can zoom down onto the surface, onto this AE map, and I can also watch a sunset from a flat Earth model. If you just want to bear with Ranty on the video, this is from a guy called Steve Torrance. All credit due to him. I was blagging obviously about myself, but would you take it more seriously if it was then modeled using real world data, using a real sun on a flat Earth model, and it looks like this?
Me personally, no. I mean, I work with maps, yeah, and that's why I'm very, very sure that the Earth is a globe. I've been working with maps for about 24 years. You know, the fact that we can put something into CGI and show something happening with the sun, I mean, unless, you know, you go into specifically what the model is doing and how that's working, I don't find it very convincing, because I know the distances will be wrong, and, you know, we can get into a discussion about distances. Yeah, I mean, I think this is the problem. You can mock some things up to work on the flat Earth in one domain, another domain, another domain. It's when you assemble the pieces, you know, you don't have a model that's consistent, because there'll be a lot of other anomalies. You know, and all good attempts for someone trying, but we know the distances will be wrong. We know the AE projection has got incorrect distances in it. So I don't know what this is supposed to show me, Glenn. Maybe I'm not understanding the explanation.
It's basically of having a wishy-washy photograph showing, yeah, the sun just bends down through refraction and it disappears like that. This is physically showing a circular sun going above you on a flat Earth model to scale, sat in a 3D model. Basically what Slice Barkane or any of the globe earthers cannot do and cannot show. He is actually showing how a real world sunset works on a flat Earth model by just the sun moving away.
And then I think the interesting question would be if we do the Eratosthenes test, with some sticks in his real world model of his model of the sun going down.
He built it on that.
Yeah,
on multiples. He actually had 50 data points. Yeah, if you look up, it's Dr. Zach's best friend. He's actually part.
But he's going to be putting a load of bending things on the horizon, isn't he, to make sure it disappears, right?
What it was is that they first started off and they had zero account for any refraction. So they used the raw data from JPL and it didn't look right. It didn't actually match. But they've done a massive series. It's like a 3-part series. Each video is 50 minutes long. And the first one is just an introduction to their model, how they've built it, what they've put in there. The second part was, oh my God, it doesn't actually look right. It doesn't match reality. We need to look at refraction. How can we represent refraction, the atmosphere, and a first-person view? So they looked into it, and they actually found that 3ds Max has got this just generic tick box that says add atmosphere. They added atmosphere, and it almost perfectly lined up correctly as to what it should do. It bent all in the right places. Star trails started to look perfect, and it's literally like that. And the sun set like that.
So I guess the issue with that is this. I can take Stellarium, which is modelled on the Earth and works perfectly, and as we saw with the Ali B picture, exactly matched something that Ali B said obviously was impossible. We took the same time of day, we rolled to that point in time in Stellarium, and it exactly matched. And by the way, it looked very, very good, the rendering of it as well, the picture that Ali had. Okay, I don't know if you've seen that particular video I'm talking about. It matched perfectly, right? So the fact that these guys have modelled something else, I really highly doubt it, because I suspect you can find situations and observations of the moon, the planets, and the sun that probably won't work in their model. Of course, that would be interesting to try. But I mean, we have a model that we can use and predict things.
What
when
if
I look for stars? Sorry, go on.
Yeah. On the same model, on that same. If I chuck up a counter again, Ranty in the chat. If I chuck up a counter, there's a guy who has basically got Stellarium. He's recorded it for a particular amount of time, and then recorded, and this in one direction looking directly south, and then recorded a certain amount of time looking directly north. Run them side by side just to see if there was any familiarity. Come on, Jack, sort it out. Any familiarity. And this is what he saw. Now, I know they're not identical. However, they would not be on a flat Earth because the stars are much closer. But if you see there on the left-hand side, looking directly north, now he is running them synchronously. So they are identical. One looking north, one looking south. And yes, you can say immediately, straight away, just to hand wave dismiss it. Oh, yeah. Yeah, it's bound to do that. There's so many million stars in the sky that it's bound. But if you're getting a shape like a dipper looking directly north and the same one inverted looking directly south on the same program you're using, put it this way, it's a spanner in the work.
Well, I think Stellarium's pretty good, as I say, when we modelled an observation from Ali that was real world. Obviously, I don't know, and I'd have to look at whatever this guy is actually doing. So showing these things, it's like lots of propaganda. Yeah, I'm not sure it shows a lot until you look at it and understand exactly what the person is doing. They may misunderstand something.
You'll have to do it yourself. If you've got Stellarium yourself, all you need is a free open source screen recorder. And then if you know how to just do a reverse, a basically reverse, try it yourself. I've downloaded Stellarium. I know exactly what you're saying.
We took Ali B's photograph of the moon. Ali said, this is impossible, right? It's a flat Earth. This is impossible. The moon cannot be lit like this with the sun 180 degrees behind me. Yeah?
No, I know that. Yeah,
we modelled it. We put the picture side by side. It literally was perfect. So I've got a lot of confidence in Stellarium.
Yeah.
I know that, but what I don't think you're not understanding is that it's scale invariant. So the same model will work if you squash everything in and shrink everything. At certain points, there will be certain sweet points where everything matches identically. You cannot tell the difference between the distance, let's say.
I guess the point is, Gleam, hundreds of thousands of astronomers are using Stellarium. I think it's likely they would have pointed out major observational differences, unless you say they're all in on the conspiracy, which
no, there's no. That's the more point of view I come from when I was saying about entertain the thought experiment. Yeah, don't try and put obstacles in the way to say, yeah, there must be this massive conspiracy, because what if nature is presenting herself as it could be both? What it is that you've already got it set. You know a model that works, and let's say, yeah, cool, we've built this model, a heliocentrical globe Earth model, which works perfectly. Flat earthers can't knock it because it works. It predicts everything to a T. However, when you use those same rules out of the solar system, they don't work. So that's where flat earthers have a point. They have a point to say that, well, wait there, 95% of the universe has to be this dark stuff, because the actual physics laws that you're telling me is absolute doesn't actually work. And
yeah, I'm not talking about outside the solar system, because I've got big questions about dark matter and so forth. But what I'm talking about is, the Stellarium model with the moon, sun, and stars tends to work. There's not been a lot of people complaining that they're finding these anomalies. Yeah. People look for knocking holes in lots of things. So what I'm saying is it's a moot point. I don't think it's proving a lot. I think I'm very confident that Stellarium mimics these things very well. As I say, I've looked at a number of areas myself. I'm pretty confident in them. The Stellarium thing the other day did impress me when we got exactly the real view. We're not at that level, certainly with observations of ships and things going over the horizon. And I guess then there's more areas to look at. Is my respectful way of, saying that I'm not finding some guy on YouTube who's found some vague anomalies that he says are there that convincing at the moment.
Yeah, you see, I see it from a completely different aspect. Is that down on the surface of Earth, what we can empirically prove, because we're so small on such a large surface, we can barely falsify either model. So you can say, yeah, well, that is a flat Earth. You can see a bit more than what you would do on a globe, and then you can say, yeah, well, it's a bit more refraction. It's a lumen, and you can see a bit more. But it's the clue is in the long distance tests of what it is, and obviously in the massiveness of the solar system.
I guess I've got a model. I can predict, eclipses. We can look at the analemma. I can bounce and receive signals from satellites that are then blocked as I expect them to be. I can see something I think is the ISS going overhead. I can even get pictures from that. I can look at data, raw data, as I say, from these reflectors that are on a thing called the moon. I believe it's a physical object, and then people went there because I've seen the data that's come back from that. There's a number of things, that I have definitely verified, which gives me the confidence in, if you want to call it the model or, the globe Earth. Mm-hmm. And I'd love to see, which is why I'm quite interested now in these long distance observations, because it's not an area I've at all looked at before, right? The photography bit. Yeah. A lot of these other aspects I definitely have looked at, and I've got some, what I believe is good evidence for those, which is why I'm more interested in the areas maybe that I haven't looked at. And I take your point. I know what you're saying. It's a philosophy about entertain the idea, and I'm quite open-minded, so I'm not entertaining the idea, but I'm very skeptical about, because I think there's a deliberate, I think there's a lot of people very keen to prove things that reality matches ideas. And I'm someone who's probably a little bit less sure of going out on a limb on certain areas. Let me put it like that.
Yeah, no, I get that. And I'm not.
I'm not sitting here bashing, going, you utter idiots.
Yeah.
Of course, it's a super looming refractive hyena, whatever, and Ranty was wrong, and Ranty's an idiot, and he never was on the beach, and he wasn't 4 foot, and he got it all wrong, and he doesn't know his arse from his elbow. that's not my style.
No, I get
Because
that.
life has
I get
taught
that.
me that there are odd things happen and there are anomalies and there are things to be discovered, right? So that's why I keep that level of respect.
That's it. No, I do get that. I get that fully. Put it this way. I can't tell you, I can't say to you, you're stupid for believing the globe, because I still believe it's a possibility. And there is no way I can not believe it's still a possibility, because I don't think that there is anybody fit in the whole scene to even falsify any of the models. I reckon both of them present each other as they present each other, and they work. And it's only these long distance tests that actually give you the hint and the clue.
But how about all the people, and there are a lot of them, who are day in, day out, I don't know, surveyors and astronomers, and like this guy that I contacted, this observatory, right? Those guy, yeah, who may theoretically be in on something, but these real people who are doing a PhD and whatever, who are doing this stuff. This guy who spent, I think 15 years now firing lasers off the moon because he wants to look at general relativity, right? And that's a good way of doing it. I find it very hard to think that those people, and when you see all the photos that I put in the thing, you'll see there's a lot of effort goes into it and a lot of work.
Yeah,
and
sure.
a whole career.
Sure.
I find it very hard to think that they dare, because they'd have to be in on it, you know what I mean? Because he's literally firing a laser and it's literally going into the sky.
No.
Yeah?
I don't think you need to. I think a lot of people need to delete this. Oh, he's got to be in on it. There's no got to be in on it. He's taught not to be in on it. He's taught and he knows and he believes what he knows. At the end of the day, whatever he's using and whatever is working is right, because the theory has been designed about that. Let me put it this way. There is no way to measure the two-way speed of light. Okay, so whatever time it takes to bounce off the moon, you just half, and you assume free space. Yep, so you assume that there is nothing slowing down the speed of light in between.
Yeah, agreed. Yeah.
Apart from that last bit of atmosphere, let's say they do account for that as an error margin. But if you think of it, you cannot measure one way. So obviously you can't be up at the moon and say, right, it took this long to get here. But
agreed. Yeah, you're measuring it going up and coming back. Totally.
Yeah, it's a massive known thing in physics, though. Even on Earth now, we cannot measure the two-way speed of light, one-way speed of light. We can only measure it two ways, because the very thing that we're looking to prove is the dependency of what you're trying to get. I don't know whether that makes any sense, because Jack is involved on this conversation, but you cannot measure the one-way speed of light. It always has to come back to you, and then you split it in half. Now, that theory itself has anomalies on a large scale, on a massive scale. Yeah, it's not a perfect theory. It doesn't work all the time. So if there are exceptions to the rules, let's say, then you've got to allow for let's say that it's been put clear. I'm sure you may have been on Jose's stream the other day or listening in, where Barney clearly said, yes, all current theories of gravity have been falsified, meaning that we do not have a correct theory of gravity at the moment because of this dark matter, dark energy plus quantum gravity. We haven't actually got a complete theory, working theory of that yet. So to say then, if you step back again in a much bigger picture, okay, how much does the globe model depend on gravity? And you find it's a massive core aspect of it. And to know that it fails outside of the realm it was designed in, which is this solar system, yeah, you can have a perfect working solar system model, but is it right?
So you're jumping around a lot. You've gone for a bit of a monologue there, Gleam. So I'll unpack it a bit.
Sorry.
The first thing you said is you can't measure speed of light in one direction; it has to come back. True of the observations of the moon, but not true otherwise, right? LIGO definitely looks at and CERN at measuring light in one direction. Okay, so first point. Second point, where you're bouncing it off the moon, whether it's got something else in between or not, he's measuring from something that is on the moon, which means space is real, the moon exists, and there's a mirror on it, because he's definitely bouncing these big lasers that are green off something, And it's not just bouncing off the moon's surface, because I've shared the results and you can actually see the results, right? Okay, that the guy shared with me. Yeah. So I'm 100% believing that there is something on the moon that it's bouncing off. How that got there, we could debate that, whether it was men and astronauts or unmanned missions. I'll accept a little bit of something around that, but there's definitely a thing there that's bouncing stuff back. The next point you came to is gravity. Now, I'm very comfortable with gravity on the Earth, pretty comfortable with it within the solar system. I take your point about dark matter. It's not something that interests me. It does interest me, but not in terms of this debate. The fact that we haven't answered all the questions about the whole of the solar system, given we're a tiny little planet on one bit of the Milky Way in the corner of it, doesn't surprise me that we haven't got all the answers yet. We certainly have got the answers that we need for our model of gravity on our Earth. And I know Anthony Riley likes to go on about gravity and say, well, you can just ignore it. It's not the current science. We all know that's a trick, right? It's a trick because we all know that there is an effect, whether you want to call it gravity or dropity or pull something to the earthity. Yeah, we see that effect. It occurs. It happens. It's measured. We've got lots of observations and theories based on it. And on this very channel, I had an interesting debate with Anthony, around pressure in relation to obviously that gravity. And then he's not here to defend himself, so I'm not going to knock him. It's not what I'm trying to do. But I think, I'm very comfortable with the current theories of gravity. So are the hundreds of thousands of technicians and scientists working with it day in, day out across the Earth. So this is where I find the model quite naive, is there are bigger questions to answer. I totally agree with Glim. Dark matter it's gone a huge amount in the last 20 years and will carry on. But I think we can be very sure, or certainly I am very sure, about a lot of the things that I was taught at school. And I don't think there's massive anomalies to find in those models.
Just so you guys are aware, 15 minutes I'm going to round up, so
That's no problem.
Just thought I'd let you know, because I don't want it to drag on too long. I know.
Sure. Yeah, I have been monologuing. Sorry, Jack is getting involved, but just a quick fire back. LIGO is definitely two-way interferometer, so it bounces the light.
Yeah, LIGO is two-way. I agree.
Yeah.
I agree. Yeah, I misspoke. I saw the video the other day. I had LIGO and CERN in my head. Yeah, I think CERN is one way, but I think LIGO is two-way because it's the whole them bouncing it.
CERN's just bouncing particles around in a circle. It's not. It's the measurement of the speed of light. So anyway, I won't monologue it, but the moon can be real in the flat Earth model. I know a lot of people do say it's translucent, it's a celestial body, it's a hologram, whatever. There could be thing, but it can be real in the flat Earth model. The moon can still be real, and even still people land on it, and it still be a flat Earth model. Even if you say, but they've got photos and it's a circle in the background, that can still be a flat Earth model.
In fact, measuring the speed of light to some degree of precision, you can actually do it in a microwave, can't you? Have you seen that experiment with a bar of chocolate?
That's not some. Yeah, the degree of precision is about 20%, and that is not an error margin that you can deal with.
But my point being, Gleam, it doesn't always need to go there and back. Yeah. Show me some citations that say that it always needs to go there and back. It always needs to go to something and come off it. Because
it doesn't need to. It's a known problem in physics of being able to measure one-way speed of light is a massive problem. There's a Nobel Prize in it.
I suspect that you're talking about because there might be elongation in the direction that it's going, right? Which is the same problem I think they had with LIGO, right? Because I think the whole point of LIGO was the gravitational wave that was coming through LIGO actually makes the light longer that's in it, yeah, and makes the measuring tube longer. Because I was watching that video yesterday, just because LIGO is quite interesting, and the guy was saying if your ruler's stretching, do you see what I mean? It's really hard to measure something, and then he gave a articulation of how they work around that. So I don't disagree with you that I think there are problems, but it depends whether there's a gravitational wave there or not. It'd be interesting to look back at the history of how they measure the speed of light, actually.
Yeah, I mean, there is a very interesting thing is Louis Essen. Louis Essen is the guy who invented the atomic clock, and he was absolutely against, and actually officially wrote against, a paper against Einstein's relativity, saying it's nonsense. So that's another investigation. I've just put in the...
Again, I think, being a little bit mature about this, there's a lot of physicists butting heads against each other, knocking each other's theories and so forth, yeah? But the fact that someone's got a different theory or a different view does not really completely, immediately invalidate a number of consensus-based observations. So it is again like when Anthony goes, well, all the latest theories say that gravity, gravity isn't a force, it doesn't exist, it's been negated. Really, those people do not believe it's been completely negated. All those people publishing that are just interested in explaining that it's a pseudo force, and they're getting into their big debates about whether it's bendy space-time and it does mass bend space-time. They're not people who think that gravity is not a thing, and therefore the answer is relative density, for example, right? So all those people he's citing do not just believe it's been turned over; they're just interested in the bleeding edge of their discoveries.
Yeah, no, I'm the opposite end of Tony. Put it this way: Newtonian works to an extent. Relativity works to an extent. Neither of them work properly, fully. As to a scale invariant, let's say, as to what a physical law, a universal law should work.
No, I agree. There isn't a universal law yet. Yeah. Newton is perfectly good for most things we need, unless it's very, very big or very, very small. And I agree. Then you can get into relativity and use that. Yeah. These are complicated things, which none of the people's views on it negate anything that we do day in, day out.
No,
where we're looking at forces on bridges or designing stresses and things. Yeah.
No, I agree with that point of view. I think where Anthony's coming from is more of a point of view of terminology, more that there needs to be a force. So the terminology is not of a force. However, obviously everybody knows the standard chorus line, but it manifests as a force. But regardless, either way, it can work. I could make up something that makes things fall at 9.8 meters per second and call it skibidi-bidi-bidoo, and make up a complete new theory that just identically matches that, but just has a slight little something on it that when you get out to the universe, it changes everything.
Yeah, you could. I agree. Yeah, and you could call that whatever. I go with the consensus, which is built the technologies that we use, right, which are incredibly useful, which is why I find Nathan's debate very odd, where he says, is a pseudo-Ramonian, this, that, and the other, space-time bendy, blah, blah, blah. As I say, we know the normal thing that he says. If you were really right about that, then you should be Nature, peer-reviewed paper, blowing it wide open, if that's really the case. Now, of course, it isn't the case. A few hundred people with a fringe interest have not suddenly discovered a major new flaw in the world, right? It's just not the case, and I won't accept it is, because it just isn't. Yeah, it doesn't mean there's not things to find, doesn't mean there's not questions to be answered. There are, right? I just because if that was the truth, if I'd suddenly found, for example, a free energy device, if I'd found a second law of thermodynamics violation, that would be incredibly interesting. You see what I mean? If I'd suddenly found how to arrange magnets so it would perpetually go round or something, yeah, that would be that would be someone finding something.
You know what I find so interesting about this whole second law of thermodynamics discussion, where everyone says, right, repeat it. Everyone understand what it is, and everybody obviously understands that entropy always increases. Now, that was actually changed way back when quantum mechanics was first introduced by Ludwig Boltzmann. It was completely debunked then. And he actually changed it to entropy almost always increases. And that's what made him give birth to statistical mechanics. If you look up Boltzmann's universe in a box, that is the main thought experiment that he used. And what he basically said is get a box, put a universe in it, our universe, whatever, blow it up, big bang it, it expands, it hits off the corner of the box, and there will be one point in time, at some point, whether it's billions of years later, tens of seconds or something like that, there will be one point in one time where that will all collate back to each other and all rejoin. And that gave birth to statistical mechanics. That's how that branch of science become known, through him and the second law of thermodynamics. And what it actually said is that there is no law in the whole of science which is actually absolute. It's all probabilistic. there is no law of science which is true 100% of the time. They are all probable to happen.
No, that could well be true. I have a problem with the second law of thermodynamics, that we do see things that do build up. The Earth is an odd one, right? We see growth and accretion and things that seem to violate the law a bit. In some cases, right? You shouldn't get, more order. And we do seem to see, I think, some examples of more order, which is why I struggle with it a bit. I mean, obviously, I know the theory, and generally it's accepted. I struggle that we would have humans and plants and animals, evolution, the Earth, the atmosphere, all of that seems a little bit counter to entropy, which is, it's an interesting thing.
Okay,
It's
5 minutes, guys.
You're going to round out?
Yeah,
I'm
five
fine.
more minutes.
Okay.
I just want to see if the plain truth is there, if he's got anything to say.
Yeah, I mean, I really appreciate this conversation, and you just welcome your input, guys, when I put out videos and whatnot. If you guys can help me talk through, and if you feel like you want to contribute at all or not, that's fine, obviously, right? But I think I'm just trying to work through the same stuff that Randy's been working through, and I'm catching up a little bit, in terms of being behind the times and not having as much time behind the camera as he has. But I absolutely love it. It's an addiction. It's my I love getting out there and just looking at what I can see. It's fantastic.
So that's the Plain Truth channel. So the Plain Truth, if you want to look him up on YouTube, you can find him. He's got plenty of observations out there. Thanks very much for stopping by. I will say
this. Yeah, I will say this, though. If you do search for me, the way that you can get me immediately is if you put karaoke in the search. It'll come up right away. Otherwise, you'll have to hunt for me.
Right. Okay. Okie dokie. So you two guys, have you got anything to finish up, to round up with what you've got to say, Toady and Gleam?
Good conversation. I really think the beginning was sort of more vigorous because we're running out of energy. It's getting late. I think it'd be really good to do some more of those joint observations, and I'd really appreciate getting the stuff from Travis. Would be fantastic for me to look at. I really want to look at a number of observations of the same thing from the same place with good data. I think, I'm quite excited about looking at that. That's really interesting. And then, I've got this thing coming out on the laser stuff later this week, once I just put the front of that together. And that's about lasers and bouncing them off the moon. And as I say, I've contacted a scientist. I quite like to reach out to people when I do these things to try and get some, some expert, information. So should be quite good. Look out for that, please.
Okie dokie. Gleam?
And if I just want to say, I'd like to shout out all the waves that have been neglected by all the globe Earth analysis on all their photographs, where they've just completely neglected any wave height. Shouts out to wave height. Love you.
Awesome stuff. Shout out to Shoaling. Shout out to Swell.
Poor Swell. Poor Swell. Neglected.
Overlooked, I'd say. Not neglected, overlooked.
How's he supposed to grow up to be a tsunami?
Well, thanks for stopping by, guys. I do appreciate it. It's been interesting talk. It's been nice that it's been a civil talk. Quite often we get, not that quite civil. So it's nice to have something interesting to talk through. And fair play, Toady, as well. I mean, you played along very good, and you did everything that we wanted. You didn't try to obfuscate the points when I asked you to put the lines in and stuff, and you was quite honest with your responses, which is all we're looking for, really. We're looking for an honest debate where people are trying to be honest with everything that they're saying, and you seem to be doing that quite good. So I'm more than happy to have you back again and again.
Yeah, I'd probably get criticised by the Globe side for not being too hard, but I'm not trying to be hard. I'm just trying to look at what we've got, and I'm sure we'll get there in the end. It just might be a bit slow, the whole process. So I appreciate that, Renty. Thanks.
Good stuff. And Gleams, thanks for stopping by again. And the Plain Truth, again, thanks for having you stopping by as well. So with that, guys, I'm going to round up. It's been my first stream in a week, so I have maybe been a little rusty, I don't know, or maybe it just went really cool. Either way, thanks very much everyone for stopping by, and I guess I'll see you tomorrow evening. I'll try and put a show on tomorrow night for you too. And yeah, I think that'll do. Until tomorrow. See you later.